Ks Gandhi is a energy energy expert, and he will address us for an half an hour. And also I welcome Dr. Shiva Prasad, the EPTRI from EPTRI, and Dr. Anita Madam from University of Hyderabad to deliver their lectures, and they have accepted our invitation. And similarly, Dr. John Saab from IIT Hyderabad. I welcome all these speakers. And we are missing one speaker from Wali Manik from ASCII because she has got some trouble. And actually, we have planned 7 lectures for 4 hours, and only we have 6 lectures because Madam Wali is not coming. So I welcome you all and all the participants who have seen our invitation of the Zoom, and I welcome all the participants, and let us have a wonderful discussion this morning. And I welcome you all for this symposium. And I thank you, Brigadier, for arranging this wonderful symposium on this day. And I welcome once again our General Secretary, ISCA from Allahabad. Thank you very much. Next.
Thank you, sir, for an amazing welcome. I would now like to call the President of Palestrijna, Brigadier P. Ganesham Garu, for opening the session.
Thank you, Prerna. Good morning, all the speakers and the participants who have taken pains to join us today. One thing I would like to share at the outset is that the kind of a response I got from the eminent scientists in Hyderabad, and I just called them or wrote a mail. They were so enthusiastic, and in the short time they all came forward. I think this speaks of the commitment of scientists for the development of society. Every opportunity they get, they would like to share their thoughts. What more we want from the society. As an elder, I'm 70 plus, an elder of society, it is a great sign in society where intellectuals want to share, meet, notwithstanding the kind of platform or the pride or any recognition, notwithstanding that they would like to share what they know is something phenomenal, and I'm very proud of the society. The topic which is selected by Indian Social Science Academy for the national conference for this year, 2022, the 45th conference, Energy, Environment and Health. I think it's a very deep subject which affects the entire humanity. And I think it is relevant, and the pandemic which has come and troubled us for the last 2 years and troubling us too, has really accelerated the necessity of looking into these 3, health, environment, and energy, so that we keep something for the quality of life for the future. The attention of the nation, of the international, the entire world has to be seriously focused on these issues, so the quality of life doesn't suffer for us and for next generations. The topic is timely, I think, very timely, and I think all of us have to think about it. Palestrijna keeps walking into the villages, and when we find something very interesting there, like a harvester which is given to them in 90s, it creates the problems of environment for them, because when it cuts at 8 inches above the ground, a big stub remains, and the balance stack, the grains are cut and taken into the harvest, but the remaining stack also falls on the ground, is thrown on the ground. Now, legitimately, farmer is supposed to get the grass and the seeds, but here the grass is denied to him, made into 2 small pieces which cannot be collected. It's very costly to collect. Now, what he does, he burns. Now look at a mechanization, energy is we have given it to solve a problem, but created a new problem. Now, this kind of a deep understanding of what we give it to, what we do in one particular vertical like health, energy, environment, the implication of that and other verticals, other interconnected, interlinked areas of society, environment, society, they also have to be studied. And it's not that we study after the pain started or the trouble started. We must study before we introduce them. Similarly, we have I remember once the milk yield of the buffalo have to be increased. So the farmers in Maharashtra, Madhya Pradesh went to the veterinarian. They said, do something about it. So he gave steroids. And then went on the 20-30% milk introduced as the yield has increased. But after 2 years, the entire area of 100 villages, the girls started growing hair. There was an imbalance in the hormones. Now, this is the link we have, the health and environment and the commercial activity. And similarly, mastitis of animals. Recently, Dr. Sunita Narayan has conducted a study on this, how the antibiotics given to animals for removing of, for treating of mastitis, any other thing. That has, the animal is treated, milk is taken, but a withdrawal period of antibiotics has not been followed by the farmers. They have no idea about it. So therefore, she found that there's a lot of antibiotics mixing with the milk and being supplied at a chilling plant level. So these kind of interlinked good and bad adversities have to be seen. So in this connection, we thought of getting the wisdom of the Hyderabadi scientists, and thereby the small half-day session has been made. And I'm sure we're going to have very intellectual high discussion. And out of 6, Dr. Valli Manikam is not coming, out of 7. But even Dr. Anita has not come so far. I'll be contacting her. But we have 5 speakers already present, and we look forward for their wisdom, sharing their wisdom. Thank you very much. And once again, I welcome on behalf of all of us.
Thank you so much, sir. I would now like to heartily welcome the guest of honor, Professor M.D. Divakar, IISK, to give us a message on the spirit of 45th ISSB. Before that, I would like to give a small introduction about our guest of honor. Professor D.M. Divakar is General Secretary of Indian Social Science Academy and Honorable Director, Development Research Institute, Jalsain, Bihar, and a former professor and head division of economics, former director of A.M. Sinha Institute of Social Studies, Patna, and he also holds post-graduation and PhD in economics. He has been a recipient of many scholarships and awards, including UK ODA, Technical Operation Training on Applied Social Sciences Fellowship, Postdoctoral Fellowship, ICSSR, New Delhi. He has published over 80 research papers and articles, and besides publications in reputed journals, including Economic and Political Weekly, he has many books authored and edited to his credit, such as Agriculture and Industry, Dynamics of Imbalance in India, Emerging Agrarian Relations in India, Land Reforms and Human Development. He has been a member of many official committee and professional bodies of government and other national organizations at various levels. So that's it for sir's introduction, and I would like to give it to sir for addressing the speech.
Mr. Divakar, you're there? I think we lost connection. He is not there in the list of the participants.
He is joining us now.
Yeah, he is there. Yeah, Prerna, you may request him again. Divakar, you are here.
Hello, sir. I would now like to heartily welcome the guest of honor, Professor M. Divakar, IISA, to give us a message on the spirit of 45th ISSC. Over to you, sir.
Divakarji, please unmute and you may request you to speak. Divakar ji, can you hear me, Mr. Divakar? His mic is not on. Mr. Divakar, if you are listening to me, please unmute yourself and we request you to speak. Yeah, technology makes you helpless sometimes. Mr. Divakar, we see you here, but we can't hear you. We see your name here. Please unmute and we request you to speak. The technical problem is coming on and off and going. There's some technical problem. So wait for a minute. If it doesn't join, I think we'll move on and we can listen to him a little later after the first speaker. There's some technical problem. Wait for a minute, gentlemen. Okay, Prerna? Prerna, you're there?
Yes, sir, I'm there.
Yeah, now I think what we do is we'll move ahead and we'll request the first speaker, Dr. Babu Rao Garu, to share his wisdom. Request him, please.
So I would now like to call upon our first speaker for the day, that is Dr. K. Babu Rao, to come forward and introduce himself. Thank you.
Hello.
Hello.
Yes, Babu Rao.
I'm just sharing the presentation first now.
Please. Babu Rao Garu, half a minute. Please introduce yourself.
Okay. Once I share the screen, I will do that. Can you see the screen, please?
Yeah. Thank you. We can see that.
Okay. I'm Babu Rao. I'm basically a chemical engineer by education and profession, but I am by choice an environmentalist. I have been working with people on various environmental issues all these years for the past 20 years. While I was in the laboratory, I was working on many commercial and technology process design, process simulation, and safety. I think that should do. There's not much required. So I am also acting as a resource person in several universities in Hyderabad and outside also, because I am trying to share the information and concerns on the climate and ecological breakdown that is happening today, because it is a vital issue for the society today. Unfortunately, I find that there is total lack of concern about what is happening to us in the society today. We are still running around about economic growth and things like that and industrialization without seeing the consequences of how it is destroying life and how it is destroying the habitability of the planet itself. This is the most unfortunate situation. So now I'll come to this. We do science But science has its own limitations that it can tell you we can do certain things, but whether what is done in science, particularly today, science is heavily commoditized. Science is being used for profit making. So most of the research done in academic institutions and research institutions has nothing to do with the day-to-day people's problems. It has mostly to do with making profit for the companies and others. That's all. So what we do today is whether it is right or wrong is can only be told by social sciences, humanities. That's why University of Utah, when it is asking for admissions, it has made this poster saying that you can clown a Tyrannosaurus Rex, but it's not a good idea. It's not a great idea. It can be a problem. So Professor Ugobardi of University of Lawrence, he talks about the two cultures. We think that those educated and those who are trained in sciences, they are separate from the other human beings. This two cultures problem is also all pervasive. So science should be more closer to humanity. It should be more related to the solving the problems of the people, and we should stand by them. I find that in most of my interactions on issues, most of the expert committees that go formed by the government bodies to look into the problems faced by the people always end up doing something against the people, and always by manipulating science. This is my experience, real field experience. Even write to them, you tell them, talk to them, they don't care, because their immediate gratification of their personal requirements to be under some committees, to be recognized, is more important for them than actually applying science for the public good. This is what I want. For example, recently in one of the plants, three persons died on exposure to a chemical which nobody knows. The post-mortem report doesn't say anything. But the experts who are put on the committee, they simply write, they died of so-and-so chemical. That chemical does not exist under the conditions reported. That is and that goes to the judicial bodies, and they simply put it in the judgment, because there is no way to, even if we write to the judicial bodies, they don't care. It's the most unfortunate way that science is being misused in this country, heavily misused in this country against the people. We say we have started out as hunter-gatherers. This is something, these are all factual, historical facts. In the Holocene period only, we have started moving towards the civilization. When we were hunter-gatherers, we were using around 5 gigajoules per cap of energy per year. That was the maximum, because it was only on human labor that they depended on. A human can produce at best 100 watts of energy, but as work, because that is the limitation. So all earlier civilizations or the empires, etc., they survived by slavery. Their luxuries came by slaves, host of slaves who were working for them. That was the luxury. So what, for example, a fan can do now, it was done by slaves, continuously sitting there and pulling the pankha. So once we have energy, access to energy, that now that slave labor is not necessary. We have new ways and modern ways of having comforts. And many modern middle class families have comforts far more than the Maharajas of the earlier days. It is certain, particularly in terms of travel and other comforts. So agriculture society used around 20 gigajoules per capita per year. And then we moved on to Industrial Revolution in 1750, which involved heavy extraction of natural resources, destruction of nature, modification of nature, and many things that happened. At that time, now on an average, people are using around 80 gigajoules per capita per year, like that. So this is all because we believe that civilization is humanity's ultimate invention and it can never be surpassed. That is one of the conclusions in one of the award-winning novels by Daniel Quinn, a conversation between a gorilla teacher and a human environmentalist who this. Finally, after the questions, they come out that this is the problem is with the so-called civilization that we have built. Because civilization cannot exist without consumption of energy. Energy consumption is key to the civilization. When we come to that, we have come to the modern civilization, 21st century, and we have all the problems that are created by extensive energy use are now evident. The climate crisis is in its fierce state. We are facing it every day. If people can see it, people can feel it. But unfortunately, it is not touching anybody's conscience, most of the people's conscience, particularly in our country. We are going as usual, as if we are 100 years back, the model of development. Same thing. We want to continue to use, we go and sign Paris Agreement, we go and make pledges at Glasgow, but here we continue to use coal, and coal also by violating all the national environmental acts. 18 coal mines of Singareni collieries have violated their environmental conditions, and they get away happily with it. There is no punishment, no action against them. And what is done is, by the so-called experts sitting in the committees, they ask them to make another report for rehabilitation and some long name they give. And they give some long name. And the consultants who give to them, they talk up nonsense. They say the company is under loss. So as if company is under loss, they are eligible for destroying the nature and violating the law. This is the kind of consultancies we have in this country. This is also a public institution. This is how they do it. So we are now facing climate and ecological emergency. This emergency is, the issue today is, we have very little time left. And our reaction time to face that situation is very, very long. What is being said is, by 2030, we have to cut down our emissions by at least 50%, carbon emissions. We are nowhere near. This year in 2021, the American emissions have increased by 6.2%. Throughout the globe, most of the countries, they have increased their carbon emissions. India has also increased its carbon emissions because we are recovering from the pandemic. So how do we meet these targets? These targets are not from the air. They come from rooted in the science. 26 COPs and 6 IPCC reports. If they don't mean anything, then there is no, then we let us go and let us have a collapse. Let us have economic and civilizational collapse. That's it. If we want to really save, what are we trying to save? Even today, the fossil fuel companies are denying climate change. That climate change is happening, which is visible to anybody who can see, is being denied by those companies, and politics aligned with it. The politics aligned with it. This is an unfortunate problem. Now, coming to this, we have knowledge inquiry or wisdom inquiry. Today, most of our education and most of our research, etc., and academics go by knowledge inquiry. It is only interested in adding to the knowledge, but not interested in how that knowledge serves. Just now, Brigadier Ganeshan has given us some examples of the adverse effects of implementation of certain technologies or certain aspects without understanding the consequences. If we look at all the technologies, you will not be able to find a technology which has no adverse impacts. Try it. You try it anyway. You cannot find a technology which has no adverse impacts. But now we are so much conditioned, mentally enslaved to this current way of life, that we believe that environmental destruction and harm is part and parcel of the progress. If we have to have these current lifestyles, we have to accept that also. That is our situation today. We are not ready to believe that we can have better life without this harm. It's possible. That's the most unfortunate, because that this current economic system is necessary for some people to make profit. During the pandemic, most of the corporations have made huge profits. Their wealth has increased by several tenfolds, 10 percentages, 40%, 50%, like that it has increased. People have become increased their wealth by several billions and billions. It's said that about 6 people or 8 people have increased their wealth by $1.5 trillion. That is the situation today. So anything that happens, this is called disaster capitalism. Whenever there is a disaster in the world, some people make money out of it. And the governments are also working towards it, helping them to make money in that. So now coming to this, whether we should have a knowledge inquiry or wisdom inquiry, we have to move from knowledge inquiry to the wisdom inquiry. Wisdom should be the basis for all the work we do, and it should be related and rooted in the everyday life of the people. Not building a big GDP and not building modern edifices and big industries. It's not that. How do we improve the life of the people? Improving the life of the people does not mean that we should have long highways. We should have more aircraft and more airports. I don't know why we don't have money in Telugu states and they want to build more and more airports at the district level. What for? Who will travel? Agriculture is in total disarray. People are committing suicide. Then who has to travel by air? It seems today in the world, 10,000 flights are empty flights are being flown simply because they have to keep that flight slot allotted at the particular airport. This is the kind of business that is happening across the world. So without changing these things, wasteful things, we cannot improve the life. Our concern, Hans Alfven, the Nobel laureate in physics in 1978, he said during medieval times, philosophy survived as a servant of religion. Today, it survives as a servant of industrial and political establishments. It is true. We have experienced it in our service also. If they pay certain amount of money, people are ready to manipulate science to suit their interests. Our concern is to help promote human welfare. That should be, rather than problems of knowledge, that we should do that. Gross irrationality of academic inquiry during the last 2 centuries or so that is damaging made possible development of all our current global problems. The problems we face today, the ecological crisis, climate crisis, and whatnot, anything you say, the enormous amounts of pollution, health problem, these are all created because of disconnect from the nature, separation from nature. Fault lies in the pursuit of scientific knowledge, dissociated from fundamental concern to help us resolve problems living in inclusive cooperative ways. We have forgotten about cooperation. We have become totally individuals. Our very ethos of Indian life, the rural Indian life, is now gone. We are to each to ourselves. The pervasion of the capitalist individualism has come to India. Now, you cannot do anything about it. You cannot bring back our rural life. I lived in a village. It was totally different, more vibrant villages. Today, if I go back to those villages, they're more like cemeteries. Many villages are like cemeteries. Only old people live there in some of the coastal districts of Andhra Pradesh. There is nobody in the elementary school in which I studied is no longer there. If the development means access to education to everybody, that is not there now. That village has no elementary school now. It is closed. This is what is happening. All our modern global crises are outcome of science without wisdom. That is what Professor Nicholas Maxwell of University College of London writes. Coming to what is the shape of, if we are talking about a good life, what should be a good life? We all aspire for that. That is what the aim of any government which professes all the planning and everything that goes on is saying that we improve the life of everybody. Nobody is bothered whether it is happening or not because they have certain indicators which suit them and they say we have improved in our ease of doing business. World Bank has actually discontinued that particular ranking. But even today, some of our ministers also talk about we have to do excel in that ease of doing business. I don't know what for. Ease of doing business was totally manipulated to suit the Western economic interests. Whoever they wanted to do some business and get their natural resources, they were giving it an improved EODB ranking so that their corporations will have access to that country's resources. This is how it is. We have become indirect slaves. The direct imperialism and direct colonialism is no longer possible. So they are doing it through different ways. So Kate Raworth of Oxford University, she talks about donut economics. It means donut is like a ring. So within that ring space, if everything falls in, all the parameters, water, food, health, what necessities, and energy, social equity and social law, etc., then you are safe. If it is inside the hollow region, then you are deprived. If you are outside, you are overshooting, and the planet cannot provide for that. Today, the problem is that certain affluent sections are actually consuming more than what they are entitled to. Because as human beings, nature has intended the human body, it has to consume so much water, so much air, so much food. Either you are rich or poor, you will be within certain parameters within the same range. One cannot consume 5 times more than another individual. It's not possible. You cannot breathe so much more air. You cannot drink so much more air, water. But other ways, the consumption of energy, there is no limit. People who are rich, they can consume any amount of energy. They can travel across the world as much as they like. That is where the whole problem is coming. This entitlement, we also feel, once we grow in our positions and start earning more salary, we think that we are entitled to better privileges. This privilege and entitlement is what is causing this harm. What is happiness is gone. So because it's a consumer society, we are psychologically controlled to think that consuming more, buying more things, having more air conditioning, buying a new car, things like that is much higher quality of life. That's the whole problem. Nobody is thinking, if I am owning a car, how I am depriving the people from walking on the road. We don't think about it. Today in Hyderabad, maybe 5-6% of the people who own the car, not more than that. Most of the people who own two-wheelers, almost, I think everybody is owning. But then, what about the people who has to walk? Where is the space on the road? Where is the social justice? This is not considered important. All the tax money is spent on improving the road infrastructure and polluting more and more. But nothing is done to cross the road safely. Nothing is done for the pedestrians to walk safely across the road. This is how our misplaced development is there. So whenever you have to live with, one problem we have to recognize here is this planet is in the Goldilocks zone of the solar system, where it has conditions for human habitation and life on the planet. It is life on the planet which has produced conditions conducive for life. 21% oxygen is generated not by any superpower, but by the organism itself over a period of time after the earth was formed. So it has been continuously balancing and keeping the earth habitable. Now today we are taking it from habitability to uninhabitable region condition. That is because of the particular socio-economic system we have chosen. Is that socio-economic system absolute? Are there any scientific basis for that economic system? Are there any laws like physics or chemistry in economics that say that this has to be done only this way, this cannot be done by other way? Is there anything like thermodynamic laws, first law and second law of thermodynamics? Nothing. So why are we going for that? And ready to destroy the planet just because somebody has to make more money. This is the most unfortunate part. We have to continuously think about this. And this is not being discussed. This is not being taught or this is not being debated in the schools and colleges. And more than all these things, how many of our students understand about democracy? How many of the students understand what is deliberative democracy and what is participative democracy? All of us vote once in 5 years, And that there ends the matter. We are nowhere to be seen or heard in the democracy. And somebody who can spend 100 crores or so much money, 50 crores, he will become a member of parliament or member of legislature, and he will do things as he likes. There is no connection between the people and the people's representatives, so-called representatives. They do things on their own. There is no feedback. There is no interaction between these people. This is unfortunate situation. The whole world also today, what is being said is the democracy itself is in danger across the continents, not only in India, everywhere. Even in the United States, people say that they may anytime go into a tyrannical leader is possible to emerge in the United States like Hitler. It's quite possible. Now the society is ready for that. Environmental crisis arises from fundamental fault. Our systems of production in industry, agriculture, energy, transportation, essential as they are, make people sick and die. This is what Barry Commoner, an eminent environmentalist and scientist, who said that it is industrial production. The pollution is embedded in industrial production. We don't have any technologies. We talk so much about green technology, green capitalism, green growth. This is all bogus. Because the industry is not interested in all this. It is interested in only making profit from quarter to quarter. That is what they are meant for. What is good for the people is not important for them. If they can sell the product, other things are unimportant. That's why we have all the pollution solving technologies that we talk about here are all end of the pipe solutions. We don't eliminate, we have to prevent the pollution generation. End of the pipe solutions are always wasteful. So, for example, if you have a pharma industry, every 1 kg of product produces nearly around 20 kgs of waste. Final product, that much waste is produced because it's made in several steps. Each step has certain conversion. So the waste piles up. The molecular economy, atomic economy is very, very poor there. So how do you make it green? How do you make it green? How do you eliminate it? So for control of pollution is a myth. You have to only prevent pollution. This has been all debated and written about also. Barry Commoner himself has written a book in 1998 or something. It's called Making Peace with the Planet. He has given examples. For example, you take an automobile. The automobile, you end up the pipe, you put a catalytic converter and try to reduce the pollution. How much you can reduce? 5%, 10%. You cannot 100% eliminate it. But what is the total number of vehicles entering onto the road? You balance them. So ultimately, the total pollution increases. It never decreases. The efficiency, if you are increasing, as Javan's paradox says, that it leads to higher consumption rates. Coal, he said, if you are saying coal is cheaper, more and more coal is purchased. More and more coal is used. If you make an automobile which runs at higher mileage, then more and more petrol is consumed. This is how it happens in the market. So we have ozone layer depletion. We haven't totally solved it, but we have moved in the right direction there somewhat. Global warming, it is because of the excessive energy use and particularly burning of fossil fuels. Then what are the indicators for what we are seeing today? Enormous amounts of air pollution. India, with its current state of development, is one of the worst polluted countries in the world. In every other indicator, we are somewhere near, beyond 100 in the international ranking. But pollution, out of first 20 cities or 14 cities or towns, the most polluted are within India only. Water pollution, land pollution, accumulation of hazardous waste, water availability, increasing temperatures. Already the temperatures have increased by about 1 degree centigrade in India and across the world, on average 1.1 degree centigrade. And say in some parts of the world, the temperatures have already crossed the Paris agreed limit of 1.5 degrees centigrade. And when they become 1.5, within this particular decade, the global average of 1.5 will be reached one time at least, but it will actually reach by end of 2030 and it will remain there. but we may experience that 1.5 even before that date. Even before that date. And at 1.1 itself, we are seeing the damage, forest fires, so much of drought, so much of floods and hurricanes and cyclones. We have seen floods in Rayalaseema, Anantapur and Kadapa districts. It is because of climate, but nobody talks about it. Nobody talks about it. No, none of the states have any plans about facing the climate crisis, even now. And the so-called reports made for some consultants are shit, you can say, use that word, nothing less than that. There is no understanding of what should be done. Simply, you have to earn some consultancy money by simply filling some pages. It doesn't bother about whether it conforms to the science or not. Industrial civilization led to allow energy. Without energy, there is no civilization. It is a key issue, lifeblood of civilization, energy. Civilization is an ever-growing heat engine. It is like it keeps consuming. If it is a heat engine, second law of thermodynamics applies to it. That is the problem that we are facing today. When we are using more and more energy, then it is unusable energy is increasing. It has to be thrown out to the space. Because of that, surface temperatures have to increase. Even if we use solar energy also, it has been calculated by Tom Murphy of University of California, Berkeley. He said, if we use the entire solar energy that falls on the surface of the earth, if we use 100% of that energy, then we will have water boiling conditions on the surface of the planet. There is a limit for how much energy we can use to keep the planet livable. Simply because I have technology, I will use that so much of energy is not possible. So extensive use of fossil fuels is causing climatic and ecological breakdown. Now, for the last 11,700 years, we had Holocene period, which made it possible for a settled life for the humans, and then development of civilization, cultures, kingdoms, so many civilization, Indus Valley civilization, Greek civilization, Roman, Egyptian, Mayan, all these civilizations were possible because of the very stable conditions of the climate. Now we have disturbed it. Now the human operations are at the planetary scale. The human constructed material is now surpasses the nature's. It's about 1.1 trillion tons of construction has taken place by the humans. Social and economic inequality has increased enormously. We are seeing it. Today, we have the highest amount of inequality. That's why recently, even the American corporates, richest billionaires, they made a statement. You want pitchforks or taxes? If you don't pay the taxes, you will earn pitchforks. That's what happened in the Paris Commune. Like that. 5 planetary boundaries are beyond safe limit. Recently, on 18th of January, this January, a paper was published. Till then, there are 9 planetary boundaries. I think I will go to the next slide and explain. Okay. Before that, we will see this. So we are so much for economy that we trample the environment, and we do not think, nobody appreciates the fact that there is no economy without the nature. Economy cannot exist in vacuum. Economy requires raw materials, energy, and they come from nature, from the planet. Without minerals, without water, without oil and coal or whatever energy, how your factory will run? What will you produce? Nobody bothers about it. What they see is only profit and money and employment. How many people are employed? Can this industry employ everybody on the planet? Impossible. Impossible. We are seeing in Andhra Pradesh and Telangana, how many engineering colleges were set up? How many engineers are roaming on the streets? Why do we produce so many engineers, half-baked engineers, not even half-baked, even the 10% baked engineers maybe. They don't understand anything. They're sent out with degree certificates and they can't find employment. And nobody needs, we don't need so many engineers. We don't have that big economy. We are not producing like China, the factory of the world. And China is paying the price for it, being the factory of the price. They have lost so many water bodies, so many rivers, so many streams. Tremendous ecological damage they have caused for the so-called prosperity. Unfortunate situation is any social system is after this profit and power. They're not linking people's life to nature. This is an unfortunate situation. Everybody is following our rulers. The Western thought that has been brought to India and put seeds into our minds. We continue to think. Nothing original in our economics. Nothing original about our past. It is all we are only hampering for the same kind of technology, same kind of production systems, same kind of destruction like our rulers, British people have done. We have forgotten what Gandhiji said us. He said that God forbid us from taking the path of the Britain. But that we are not bothered about it now. So the planetary boundaries, there are 9 planetary boundaries identified by Earth system scientists, climate scientists, ecologists, and all other people. 27 some scientists as a group they formed together. And in 2009, they first identified if Earth has to be healthy, Earth has to be continuing to support life on the planet, what it should be functioning within. So they found that climate change, already we have crossed the boundary. 350 parts per million was supposed to be the safe limit. Now we are around 415 or something. Biodiversity, that also we have crossed along. Land system change. We have converting land, agricultural land and forest land into urbanization and plantations and whatnot. Then biogeochemical cycles like nitrogen and phosphorus. We are dumping so many chemicals onto our soil. Millions and millions of pounds and kgs of those chemicals and fertilizers. They are all ending up in rivers and oceans, and they are destroying the fertility of the soil and also affecting the health. Then recently, they could identify novel entities. Novel entities means new chemical species. Today, on 18th of January, that particular publication identified and said, we have crossed this limit also, the 5th boundary. Out of the 9, 5th boundary also we have crossed, because the chemical pollution has become so pervasive, heavily pervasive. Pesticides, plastics everywhere, oceans, deep oceans also, into the life, microplastics getting incorporated into the life forms. If any of us who have never worked in chemicals also, if we get our blood tested, we are likely to have more than 100 chemicals in our blood. They found that newly born child, umbilical cord blood, when it was analyzed, they found in all about 287 chemicals which are associated with cancer. Newly born children. This is the situation, that how we are modifying life itself. There are in chemicals, there are so many mutagens, so many teratogens, there are so many carcinogens. We are all putting them into the body, and what changes it is making to life, we will not recognize it now. It will take years. And we may never recognize also, because we don't have that much time also. Next. Out of the planetary boundaries, these are all the limits that are given. The chemical pollution also has now crossed the limit. 5 are crossed. Only 1 is not defined. And out of 9, 6, 3 more boundaries, still they are there. And how long they will hold is not known. Once all these boundaries are destabilized, and what use the technology can do, what use the science will do, what use the economy will do, we don't know. Nothing can be done about it. Then these are the biosphere integrity, these are the limits, 9 limits, 4, 5 plus 4, 5 plus 5, okay. Accumulation. Safe operating space for the planetary boundary of novel entities exceeded since annual production and release are increasing at a pace that outstrips the global capacity for assessment and monitoring. This is Environmental Science and Technology on 18th January 2022. They claimed that in that publication. There are so many articles were written about it in Guardian and other major papers. So sustainability, the sustainability is the most abusive word I find. Whenever I look at these EIA reports, pharma industry, chemical industry is projected as sustainable. Coal mining is projected as sustainable. Thermal power is projected as sustainable. I don't know. They have to redefine what is sustainable. A sustainability, there are certain criteria identified by very great experts. Joseph Tainter, expert in complex systems. Collapse of complex societies. He has written a masterpiece, Collapse of Complex Societies. A society that continues to use resources unsustainably will collapse. That is how our Harappa has collapsed. That is how the Roman Empire has collapsed. That is how the Greek have collapsed. Because they didn't have wood. Wood was everything for them, energy and construction material. They removed so much of forests. Ultimately, they didn't have any way to transport. They could not extend their borders anyway because of the Pindaris. So it was not possible for them to access energy, and they perished. Population growth and our growth in rates of consumption of resources cannot be sustained. Population growth, there are populationists and the people who say that today's problems are not because of population. Most of the people in the population, they would hardly consume anything because 50% of the population in the world, poor population in the world, they hardly consume around 4 to 5% of the resources. That's all. So that is not the problem. It is basically how the resources are misused and wrongfully consumed. To be sustainable, the use of renewable resources must proceed. Even if it is a renewable resource, it should be consumed at a rate that is less than or equal to the natural replenishment. If you have a biomass, if you can grow so much within that period, you can only use that much biomass, not more than what it can grow within that period. To be sustainable, the use of non-renewable resources must be declining at a rate greater than or equal to the rate of depletion. Particularly if you have coal or oil, etc., we have to be continuously decreasing it because the non-renewable sources can never be replenished. They are not available for the next generation. What you consume is gone. It becomes ash or carbon dioxide. Sustainability requires that substances introduced into the environment from human activities be minimized and rendered harmless to biosphere. Here I give you one example. Teflon is considered as a great innovation and it is a great engineering plastic and used in many appliances, etc. But today, throughout the world, if you analyze the people's blood, we will have PFOS or PFOS in our blood. Most of the people, at least 98% of the people. Why? That was produced only in some parts of United States, not everywhere. Few places, others, by DuPont. It has become a major case. It has become a movie, Hollywood movie, Dark Waters. So how much the corporates have deceived people, how much they have manipulated science and controlled the regulatory agencies from helping the people, from solving the problem. Nowhere, whenever corporate crime has happened, these regulatory agents have stood by the people, and in any country. It is only people and some of the other leaders who have stood by them and fought the cases and won in the courts of law. By governments, hardly any time this problem has been solved. I think I will skip this because we have to say, if we have to say sustainability, simple mathematically we can say, if we have population PI in the year I, SI is the consumption of population on average. The total consumption is PI SI sigma. For the whole period, I is equal to 0 to infinity. If we have to sustain up to 0. That sigma PI SI must be equal to the total resources that this planet can offer. This planet is a closed system thermodynamically. It will receive only energy from outside, but it cannot receive material from the outside. So what is material in this planet is only fixed, and you cannot have more of it, except for an occasional asteroid, a small amount of material that is coming. So sigma PISI should be less than or equal to capital S, that is the total resources on the planet. So this particular constraint algebraic equation can only converge when towards the end P and Sn tends to 0. At a particular year n, P and Sn becomes 0. But Sn cannot be 0 because Sn is a consumption figure. If you have to live there, you have to consume something. So P and Sn can be 0 only when the population is 0. So this planet will have no consuming population. That is mathematically proven. If you have to have people and people have to consume, then we have to live sustainably. And within this is done by Nicholas Georgescu-Roegen, an economist who has first introduced thermodynamic laws into economics. Because most of the economics, it doesn't care about the possibilities, physical constraints. Simply they generate numbers. Sustainability are economic, environmental, and social. These three sustainabilities are required. Then this coming to what is enough? How can everybody live a good life on this planet? So if for a good life to be living on the planet, the Manfred Max Neef, a Chilean economist, and he has produced 9 parameters that are to be met. Subsistence in terms of food, shelter, and work, basic necessities, protection, affection, that is social requirement, understanding, participation, leisure, creation, identity, and freedom. These are the basic things. If you meet only, then we can say there is human dignity is held. We can live with dignity. Simply if you have some little money, you are able to eat and live with that. That is not meaning that. As a citizen, what are you? Many times I feel this. What are we in this country? Do we have any? Is there anything with us? Are we? Who cares about us? Who cares for our concerns? Who do you go and appeal and talk to when we say that this is happening? It should be stopped. This is the whole problem. This is human dignity is one of the great casualties, and this is not and based on this, if you say the energies, how the world is consuming energies, different countries. India is also consuming at around 800 kilowatt hours per year energy. China is now surpassed the United States because it is, after all, most of the energy China uses, all the things that are produced are going back and consumed in United States only. Instead of being produced in United States, China is producing them and bearing the pollution. So it has become a factory of the world. So most of the things produced there are not meant for Chinese, but for other people in the world. So that energy consumption cannot be put to the average Chinese, individual Chinese. Coming to energy consumption, this Professor Charles Hall, a chemistry professor and University of Buffalo, State University of New York, Buffalo, he wrote that different energy levels are required for extracting energy itself. You have to consume energy. You have to refine energy. For example, if you have crude oil, you have to convert it into products. Then you have to transport those products. Then you have to use them, make fertilizers and grow food. Then support the families. That means you have to create employment. Then you have to create education through colleges, schools, and universities. Then we have to produce an infrastructure for healthcare. Then finally, arts for for the mind to have something. So for each of these activities requires a particular excess energy. The energy you spend and the energy you gain from these fuels. Initially, for extracting oil, 1.1 is okay, more than that. For if you have to have arts and other activities, we should have a surplus energy, 14 times surplus energy by spending 1 unit of energy. Now we are coming closer to that 14. There may be energy left on the ground. There may be coal, there may be oil, but it is no longer socially economical. If that IROI comes down, you have to cut down some of these activities. So we will be dying as a civilization. We will be disbanding as a civilization because the IROI doesn't meet our requirements. Only surplus energy, the fossil fuel surplus energy has driven all this modern capitalism and the industrial capital. But now that's surplus. I think I have to close now. I think
kindly conclude, please.
I'll conclude. This is
Very
how
interesting lecture.
I know, because this is small. I didn't have much time also to cut down and put it together in a small way because it's very 2 days only I had. So this is how the IROI is going down. So solar is here, and now we are in the declining part. And now we in our country also, we are thinking of going for shale oil. Shale oil is the worst form of pollution and most damaging. Recently, yesterday I've seen a paper saying that people beyond 65 years, if they are living around the areas where shale oil is produced, shale gas is produced, they're likely to die early. This is how it is, heavily polluting. It has destroyed many areas in the United States, Pennsylvania state, Texas state, Colorado, Alabama, so many places. And in Europe, many countries have banned shale oil. Several countries have banned. Ireland has banned. Scotland has banned. UK has declared moratorium. France was the first to ban. Germany has banned. Like that. Now, this is, I think, this is inequality. How? Because we say for everything, humans are responsible. Which humans are responsible? We have to talk about. Most of the humans, 60-70% of the humans are not responsible for any of the ills of today. It is the top 10% of the richest section that is responsible for the problems of the world. They are consumed 49% of all the resources in the world. Bottom 50% consume only 7% of the resources. So who is responsible for all these problems? Simply saying humans are responsible is injustice. We have to say who is responsible. They have to be corrected. They cannot have an entitlement, and they have no business to destroy the life of other people. You can enjoy, but not at the cost of disturbing and destroying the life of other people. This is how the Oxfam has calculated, and it was published in Guardian. So 49% carbon emissions are from the richest 10%. This is 10% from the poorest 50%. This is a older one. This was before the Paris Agreement. Just before the Glasgow, another one has come. It is only 7% by the poorest 50%. Now, their energy consumption has gone down actually. Okay. Now today children are asking, it is the system that is responsible for it. We have to bring systemic changes. Without bringing the systemic changes, this problem cannot be solved. Like Einstein said, a thinking that has produced the problem cannot be solved within that thinking. This is what the current system has produced this problem, and within the logic of the current system, you cannot solve this problem. We have to build a new system, a system that it can overtake. Global climate change today are either tied to human intellect or technological development. And also coming to the material consumption also, I can tell you, in 1970, we consumed 2,200 crore tons of minerals, raw materials, and 2010, it increased to 7,000. By 2050, it is projected to increase to 18,000 crore tons. But the planet can provide us maximum of 5,000 tons per year for some time. So we have already passed the sustainability limit, and we don't have much time to continue like this. That is not progress. Then again, what is the energy consumption? Somebody has calculated. This is particularly electrical energy. An average about 1,000 kilowatt hour consumption, maybe per year per person, is probably optimum. That is they said. If they have to come down and these people have to go up, and we will be able to maintain that society. And coming to some publications, Narasimha Rao of Yale School of Forestry and others, they have done long life expectancy and access to basic needs are achievable at lower emissions than continued economic growth, but will substantial share of the global budget associate to 2C climate. What they are saying is if everybody has to have a decent life energy, that means it is possible, but it might lead to a 2 degrees centigrade climate goal. Then also they said they have produced some few more papers like that, and everybody says around 1300 watts is probably, according to IEA, it is 1300 watts. And it is possible, they say, we will be able to produce through only wind, water, and solar, WWS, that we will be able to produce that much energy and can supply to everybody. But what is happening today in our states is these governments are not giving any encouragement to individuals to put solar panels on their rooftops. Solar energy is a distributed energy. The logic of the nature is to consume things in a distributed way and network. Entire nature is a network, cooperative system. But here we want only Adani or Tatas or this body, that body, who have a huge land taken over from the farmers and put big solar farms, 50 megawatts, 100 megawatts like that, and 1,000 megawatts like that. Okay, this is the last. This is the last. I am closing now. This is the last slide.
Others are waiting.
This is how the minimum band of energy, this green you can see here, bandwidth, around 20 gigajoules per capita. That is what the energy level. We can have a good, reasonable life for everybody without this so much social and economic inequality and so much disparities. Without the heartburns, it is possible. We should go strive for it. Thank you all. Namaste. Okay. Sorry.
I'm sorry, Baburao Garu, I had to interrupt because I was waiting, but it's an amazing lecture giving so many factors. We can go on hearing for a couple of hours. And thank you very much for taking time despite your not so good health.
Thank you, sir.
Prerna, over to you.
Thank you, sir, for sharing your valuable wisdom on what is enough energy for life. And now, before I call our next speaker, here's a brief introduction about him. He was born on 24 June 1946. He has completed his graduation from Andhra University, College of Engineering, Voltaire, and Masters in Technology, Power Systems from JNTU, Hyderabad in 1991 to 94. He has done his PhD from JNTU in 2005. His PhD thesis was Market-Based Tariff Reforms, a Framework for Indian Power Sector. He has worked in various organizations such as APSEB, BHEL, NTPC, ESCI as Senior Faculty for Power and Energy and Advisor or Consultant at Vijay Electricals. Let us now invite Dr. Ks Gandhi on board. Over to you, sir.
Thank you. Can you just give me the share screen?
Yes,
you
sir.
may share. Baburao Garu, will you like to stop sharing?
I stopped it already. Stop sharing.
We can still see it, but we're okay now. Over to you, Gandhi Garu. You may share.
Yeah. Thank you, sir. Thank you. I just 1 minute. Give me 1 minute time.
तो उसका तो मार्क्स निकला नहीं है।
Welcome, Anita ji. I've been frantically trying to contact you. Thanks for joining. Anita, if you are there, Dr. Anita, you may unmute.
Yes, sir, I'm there.
Thank you. Thanks for joining.
Thanks to you. I've been in the meeting since beginning. I think
Oh.
it's not showing up. I have some video issues.
Oh, I see. Well. Finally, we can see you now.
Are you able to see?
Yeah, we just saw you. Not the video part, but we can see your box.
Okay, fine.
Yeah, can I start, sir?
Please, Gandhi Garu, over to you.
Yeah. Thank you, sir. Thank you, Brigadier Ganesan, sir, and Mr. Murthy, sir, for having invited me for this presentation. I really do not know whether it will, I mean, this presentation, this topic, whether it fits into the scheme of things, but definitely I will try to complete it within 20 minutes, the mandate given to me, I mean, by all the speakers. Anyway, sir, actually today I want to just go ahead with this presentation of these renewables in the country today. What actually I have just one more presentation, just 1 minute. I want to just close this and then go to some other presentation actually. I do not know whether I will be able to trace it out because slightly I was late actually. Yeah. Good. This is the presentation on this, renewables in the country, India. We are going for 175 gigawatt by this year end, 2022. That is the target we have put in front of us. And by 2030, we are going for 400 gigawatt. 1 gigawatt is 1000 megawatt. Well,
Gandhi, we can't see the presentation. Please upload.
yeah. Now is okay, sir?
Not yet. Wait. We'll wait. Not yet.
No, I am able to see.
No, you can see it. Anybody else? Murthy, Ks Murthy, can you see the presentation?
Sir, Indian Social Sciences
We are
Congress.
not able to see.
No, I think you have to go back to stop the sharing and go share again.
Okay, sir. Is it okay?
Not yet.
No, we cannot see.
No, I have spread it actually. That I'm able to see the, I don't know. Now what I should do?
I'm sure you know the procedure.
Okay. I will close this. You're able to see? Am I audible, sir?
You are audible, but presentation is not visible. I'm sure you know the procedure. You go to the share arrow mark, click it. Then by then your presentation will have been open in your screen, your desktop. Then click whatever you want to.
That's what I did only.
You try again. Sometimes technology fails us.
No,
Repeat
first
the
of
whole
all,
thing.
should I leave this meeting and then?
First, stop sharing.
Uh-huh.
There's a stop sharing button. It's already there. Press that. Then start sharing again. If there's no stop sharing, then press share button.
Yeah.
I think host sharing should be there. Otherwise, it may not be visible.
Sir,
So
now,
we have allowed everyone to share. All participants can share. Right?
Thank you.
able to see?
Not yet.
Not yet, huh? Not yet. Okay. Then probably give me some time. Otherwise, please go ahead with the other speaker. Probably I will just adjust myself. What do you suggest, sir?
You want us to go ahead with next speaker?
Yeah, I think so. Because you see, you are not able to see the presentation, which I have already displayed, but I am able to see. I can read out also.
Well, you can see your presentation. That's great. But how about us? So you won't take somebody's help around in the home?
Nobody is there here.
Yeah. If you permit, Dr. Gandhi, can we move on to next speaker and then we'll get back to you, revert back to you?
Yes, sir. Yes, sir. Please, that is better.
Thank you for that. Please.
Meanwhile, I will adjust myself and then,
Prerna, would you invite Dr. Renu John?
I would now like to call Dr. Renu John, who would be introducing himself. Over to you, sir.
Am I audible?
Yes, sir, you are.
Yeah, good afternoon to all of you. I'll just see if I can share my screen. The same problem exists.
Not for all, I guess.
Can you see my screen?
Yes, sir.
We are able to see.
All right.
How can IIT fail?
Fine. It's fine, right? You can hear me as well as see me, right?
Yes, sir.
Thank you very much. And thank you, Brigadier Ganeshan, sir, for this invitation. And also the organizers of ISSA for bringing these many speakers for this nice interaction. I'm Renu from IIT Hyderabad, from the Department of Biomedical Engineering. I mostly work in development of medical devices and translation of devices from lab to bedside at clinics. So in today's talk, I would try to look at how medical device or how healthcare has been impacted by the developments in technology. So we'll have a very short discussion on the challenges ahead, especially in the post-pandemic era. So if you look at the technologies that have touched humanity for the last decade, and probably technology to continue to dominate for another few decades for the century. So one of the prominent things that come to our mind is digitization. Digitization, which has touched every walk of human life, from say banking, finance, and business, management, administration, government offices, agriculture and food, energy and environment. So in fact, from classrooms to educations, we are facing digitization. Of course, there's a food for thought to think whether it has been just digitization of the old chalk and board exercise, or are we being innovative enough to get a digital classroom ready. So of course, healthcare is no exception. So information and communication technology is another area where it has been an explosion of data in recent times. So the way the data is collected, data is stored and communicated has become a paradigm shift now. So the enablers for ICT have been like the mobile communications, 4G and 5G. You can really look at, in another few years, 50% of the rural India would be embracing mobile technologies, not just for communication, but for payments, services, and entertainment. If you look at the 80s, Doordarshan in the early 80s have penetrated the country like anything. And after that, probably mobile technology is one of the technologies that influence the masses everywhere, including the rural India. So, we talk about Internet of Things. So what is IoT basically is, it's basically a network of physical things, sensors. It could be sensors, it could be data or actuators. And all of these sensors connected and linked systems through a web of internet, so that you can acquire data, sense data, communicate, share, and finally the last bit of it is artificial intelligence. How to make decision making, how to take decisions, how do we make intelligent decisions from this data? AI and machine learning have been a buzzword. From everything from your daily shopping to the sophisticated implants and surgery. Let's see how each of these technologies have been influencing our life. Now, when we talk about digitization, what it means for common man. Say, if you take the example of banking, I believe all of us have gone through these times. Probably this has become the previous century scene, like withdrawing cash from a bank. But we are fortunate enough to witness this as well as the new technologies, and it has been quite a while since we adapted to what we call as a plastic cash, where you use an ATM card to withdraw money from an ATM. So though with little reluctance among the elderly population, but still it has become a practice. It has been adopted to withdraw cash from ATMs, and along with this, we witnessed this huge queues in the ATMs following the demonetizations. But we really didn't think that there is going to be a huge socio-economical transformation following the demonetization. With even the rural India embracing digital transactions over your mobile phones. So when we talked about Paytms or Google Pay, I thought it would be far-fetched. It would take a long time for this to be adopted. But the demonetization, starting from the demonetization and the pandemic, made it possible for every vegetable vendor in the country to use Google Pay or Paytm on his table and have transactions, cashless transactions seamlessly. So, and it's, when it comes to digitization in healthcare, it's no exception. So when we talk about, medical data, it's a different story. So in digitization, we talk about electronic medical data, electronic medical records, and electronic access to healthcare from rural and the tier 1, tier 2, and tier 3 cities. And all of these things that we talked about regarding the acquisition, storing, and communication of medical data, data processing, and decision making comes here. So first of all, if you really think about where is medical data? So even when we talk strongly about digitization, currently the medical data exists in these plastic bags with the patient's hand or the bystanders or the people who are accompanying the patient. Even now with a lot of electronic medical records and digitization, except for the premium hospitals, medical data still rests in these plastic bags. It could be an MR image or MR slide or an X-ray or the lab test. It's still printed, paper printed, or on films and still lying in the plastic bags along with the patients. So we still need tremendous changes or drastic changes to get this data to a shape where we can do a data processing, take an intelligent decision from this data. So of course, it's not just for the data. How do we take data? Almost like 80% of the villages, you would still see these type of rural clinics or primary health centers where the doctor has absolutely no equipment or just a stent or a few minimum devices in his hand, and still taking the history of patient, interacting with the patient with a stethoscope, and there is no digitization here. I mean, it is all handwritten patient or doctor notes here. So the access to healthcare in rural areas still is far from what we call as a modern digitization. And this is true for all of these, like acquisition, storing, and communication of data. In fact, the clinical community has been very proactive in using even WhatsApp for taking data or communicating. So it's a positive move that doctors or even students are sharing case studies or WhatsApp, creating WhatsApp groups to discuss. But this is probably a wrong platform for clinical data, which is like you really need to look at a proper clinical platform where you can share data. So if you look at the problems in the rural India, there's a multitude of problems, starting from maternity, fetal care, the ophthalmology clinics, I mean, the problems of the eye-related problems are huge in rural India. There are endemics and pandemics and lot of epidemics like dengue, malaria, encephalitis, Japanese encephalitis, and even like sexually transmitted diseases. The rural populations, it is quite difficult to diagnose or identify substance abuse or even cancers of various origin. So, the penetration of healthcare to rural India is still a long way to go. I mean, this is the same story for medical data and records. Acquisition of data, storing and communication of medical data is still, there are a lot of challenges here. And, when it comes to communication of data, you really have to look at WhatsApp and Google for doing this. So if it when it comes to, any other application, like, with Internet of Things, Google has been pretty smart to track you in whatever you do. In fact, with the GPS coordinates to that precision, where, of course, sharing your mobile password to your spouse becomes can turn quite disastrous, because Google knows everything about you. And it can use this information for intelligent marketing, and it can use this information to find out how often I drink a coffee, or how often, or what type of biryani I order over Swiggy or Zomato. So, but this Internet of Things can also be used for surveillance applications, where you can monitor your house when you lock and go, or monitor your grandparents' safety using surveillance and internet IoT enabled houses for safety and for monitoring your child at home. So there are connected systems and sensors that boom the entire healthcare market. No matter whether you want to look at your heart rate or oxygen saturation, temperature, ECG, blood glucose levels, or estrogen levels, or the number of footsteps that you make in a day. So I mean, these connected systems like Fitbands and watches can really generate a lot of personal data. It can also monitor your bus, or track your taxi, or book a cab, etc. So post-COVID, we realized that this technology has enabled us reaching to the masses, whether it could be education, like teaching your class and learning your subjects through conference, as we do today, when we cannot have physical meetings. So, or to watch a new movie on an online OTT platform. So you can order your food, and the local grocery shops have become local grocery apps, or Apna Chotus, where it can take care of most of your shopping needs. So which also has been enabled through the IoTs and the technologies that are connected. When it so when it comes to healthcare, again, like except from the watches or connected Fitbits, which collect your personal data, acquisition, storing, and communication of medical data has been enabled through IoT. And apart from that, there are a whole class of problems, including teleconsultation, telemedicine, and telerobotics, where you could use IoTs and 5Gs for efficient, even doing telesurgeries. So there are a whole class of medical practices where people have adopted, whether it was triggered by COVID, or whether it was triggered by the need due to lack of expertise in rural areas. We could even see robotics with remote operations, where you could really do radiological applications like a sonography, where the radiologist could be far away, sitting in his practicing office and manipulating the transducer on a dummy platform, where the patient would be somewhere at another city, and you could take a ultrasound of the patient, look at a growing fetus. These are highly enablers where you could really avoid travels from patients. Where there are cities, there are cities in the country even where you have to travel 30 or 40 kilometers to get an ultrasound done, which is true even in Hyderabad. So the remote or the outskirts of Hyderabad, there are places where you really have to come to city to get an ultrasound done. So all of these could be enabled by telerobotic applications. So while considering the advantages of IoT and telecommunications and all those things, we should also have a lot of concerns regarding ensuring the data security. I mean, the privacy of the data was because the patient owns his own data, and it should not be available on commercial platforms. The privacy is important, security of data is important. At the same time, the data, instead of resting in this plastic bags, should be available so that you can do intelligent decision making on the data. So while taking care of the privacy of the data, for this, there are still policies to be made where you really have to share, develop protocols where data could be shared securely and safely. And you could really allow access to data. So this is specific to, I mean, most of these things could be taken care by corporate hospitals because they have the data and their data is secure. But sharing of the data with the patient or with another hospital or with another clinician becomes a difficulty because there are no protocols still to communicate between two different hospitals, or the patient can share this data from one hospital to another clinician outside the hospital network. So all of these have to be enabled so that you can really take an effective and efficient use of the data for decision making for clinicians. So intelligence is often heard everywhere when it comes to data. This is also intelligence, like where Alexa take your decisions or Google Assistant tell you which food you take or which restaurant you go, or what are the type of I mean, what is your cholesterol levels, and based on that you can decide what food you take for the weekend. So all of these is possible through the intelligence, and artificial intelligence has been taking a long ride on our daily life. There are people, the people looking at medical data also for artificial intelligence, because when it comes to decision making, when it comes to decisions, prediction of disease or prognosis, data is very, very important, and AI and machine learning is going to rule the tomorrow's hospitals and clinicians. So there is this widespread 4G and 5G technologies, which is going to decide on preventive, predictive, and personalized and participatory health care. Yeah. As I mentioned before, with the widespread use of smartphones, more than 50% of the rural India is getting covered with use of smartphones. There could be robots or tele-robotic applications which can take care of your healthcare checks, daily diagnosis or screenings, which can help you in preventive diagnosis or preventive analysis of your data. So there has always been a question about what artificial intelligence can do. So in fact, the clinical community or the clinicians have been quite reluctant in adopting these techniques because they feel like a doctor could be replaced by AI, which is a really wrong convention, which is a wrong practice to follow, and it is never going to happen. In fact, the greatest advantage of AI could be it can create the best of the doctor in you. So it can augment the skill of the clinician, and it can take the cognitive load of the clinician to make efficient and better decisions. In fact, it is not going to replace the physician, but it is going to make the physician better than the best. So with a lot of data available or getting the data translated from regular platforms to electronic platforms, and with faster and computing power and faster communication, we are going to get onto a highway or an express highway for healthcare applications. So there are a bunch of cases which people have already been trying to, some of the examples in vitro fertilization or in digital pathology applications, ophthalmologic screening, which are well reported already. So there are people who are taking, taking rural scannings with less expertise and ASHA workers, and the data get analyzed on the clouds, and decisions could be made in a very effective and easy way. So, of course, we talked about the challenges earlier on how to create or form policies on sharing ownership of data, how to secure the data, and how do we share the data for efficient decision-making process. So with this, I will sort of wrap my talk, and probably we can have a quick short discussion and any questions if you have. Thank you very much once again, and look forward to any questions. Thank you very much.
Thank you, Dr. John. I think you've taken us to the digital world where humans are controlled by non-humans. But I think it's a wonderful world. It is bringing, I hope it reduces the inequity between the people at the end of the day. And if that is the aim of any technology, I think we all must welcome wholeheartedly. Thank you very much. We move on, and I ask Prerna to go for the next speaker, Dr. Shiva Prasad. Prerna, unmute yourself. Prerna, unmute. Yeah.
Thank you, sir, for an amazing presentation on medical devices and technologies. I would now like to invite our next speaker, that is Dr. B. Shiva Prasad, who is presently working as Director, Water and Waste Management Organization, India. He is also advisor at Aharya Ecotech Private Limited, Hyderabad, and he was a technical advisory member in projects designed for lake bioremediation by HMDA. He completed his doctoral research in environmental nanoscience and toxicology from Birla Institute of Technology and Science, Pilani. He has more than 16 years of experience in academia and research. He has also been a recipient of Young Scientist Award 2015 from Society of Toxicology, Best Abstract Award 2014, and International Travel Award 2016 from Association of Scientists of Indian Origin, Society of Toxicology, USA. He has also received prestigious travel awards from International Society of Environmental Toxicology and Chemistry and SOT USA. Thank you, sir. I would like to give it to you for the session.
Good morning, one and all. Thank you, Ms. Prerna, for a small introduction. And I take the opportunity, and first of all, I must thank Pallis Rujana and also the ISSA for giving me this opportunity. And I'm honored, in fact, delivering a small talk on the emerging technology and environmental nanotechnology applications as a part of this gathering. Just a minute, I'll share my screen. Can you see my screen?
Yes, so we can see.
Yeah. So once again, I welcome all the participants, and also I thank organizers this online symposium on energy, health, and environment. So as a part of this symposium, I want to deliver a talk on this ascertaining environmental health and safety considerations of engineered nanoparticles for effective management of waste. So as an insight, if you take this context. Yeah.
Dr. Prasad, would you like to enlarge the slide to the maximum?
Okay. Fine now? Yeah. Fine, sir.
Yeah, we have
Yes.
it. Thank you.
Yeah. So whenever we take any technological advancements in this era of the sustainable development goals, no matter how sophisticated knowledge is, it is always be subjected to some degree of ignorance. That is already discussed in by our first speaker. And also how we are advancing. Just now we have learned from Professor John how this integration of the humans with the non-humans technologies invigorating into the understanding the health implications and also advancing the treatment systems. So to be alert and to be humble about the potential gaps in those bodies of knowledge that are included in our decision making is fundamental always. Surprises are inevitable, and by their nature, complex, cumulative, and synergistic and direct effects in particular have traditionally been inadequately addressed in regulatory uprising. So with this insight, I wanted to take my topic onto the area of the nanotechnology, the next big thing, which is very, very, very small. So nanotechnology enabling technology that will change the nature of almost every human-made object in the next century. So as given by National Science and Technology Council, US. And it is being used or applied in various areas of for example, manufacturing of the products and also designing various processes of the environmental treatment. As a part of the industrial processes and energy and water crisis, etc. But there is a promise of these environmental benefits from this technology and also sustainability effects, but there is a need for understanding what is the exact implication or implications we have from this technology. Still, we are in the naive phase, or I can say that the recent phase, so as to address so many contexts in these technology applications. So starting with this nano timeline in the 19th and 17th century, if you just move to the recent times of the 20th, so we witnessed how this technology has been enabled in so many areas, starting from vibrant colors of stained glass, the windows of the Europe, and to the today's technology where we are using this compounds in various cosmeceuticals and pharmaceutical products so as to bring them the miniaturization of the technology into the context. Simply, for a layman language, I can say that in a natural way, there is a nano material already existing. Say, for example, if you look at in a scale of starting from the 10 to the power of minus 10 meters, I can say 0.1 nanometers to that of the 1 centimeters, the 10 nanometers scale. So head of a pin, which is having almost 1 to 2 millimeters. And also you can look at the ant leg having that is a 5 micron size. So we are bringing down this material size or miniaturizing, engineering the materials to that size, which are just beyond the size of the bulk or natural materials what we have through this nanotechnology. So it is another slide which explains about how this nanotechnology is a nanomaterial, sorry, how small is nano. You can look at this 6 feet man, the 1.65 meter tall, or you can say 2 billion nanometers or the around cells of this into a strand of DNA, which is about 2 nanometers wide. So this is how the technology or the materials of the nano size or the nanomaterials are being miniaturized employing the technology nowadays. So as a result, what is happening by the miniaturization of these materials? This is mainly leading to the change in the surface area properties. And also we are employing different types of coating materials, size and shape are being altered. Then ultimately the reactivity of this material, size and shape of the materials is playing crucial role in terms of their interactions and their final fate in the environment when they are released at the end of their life cycle. So this is a problem which has to be addressed, but despite that, now already we have these materials, and because of their benefits of the applications, we witness their use in medicine, information technology, energy production, material science, to that of the tunneling microscope, and also recent technologies, whatever we are employing nowadays. That's how the nanotechnology is spanning from its types of the various kinds of applications in human things, and also applications of the nanomaterials in different sectors. But say, for example, from the estimated production rates, if you look at, in the area of the biotechnology, these materials are being employed has increased from the 1 metric ton per year to the almost 10 metric tons, 10 times increase in the area of the biotechnology, instruments, sensors, characterization. Just now witnessed from the Johnson explanation where we are trying to employ this kind of applications, which is also almost 3 times the thing, and also environmental treatment systems. We are also employing these nanomaterials. And also structural applications and skincare products and ICT also witness the application of the use of these materials. As a result, what is happening to these materials, and do we really know what is the problem being faced by or posed by these materials in this technology? So, for example, in the 1960 to that of the timeline, if you look at the level of concern to that of the around 2020, we know about these nanomaterials not much about. Still, the science of these implications of the nanomaterials is still emerging. So we don't know what exactly it is a friend or foe, we don't know. So what we have to establish the fact and figure how it is going to be toxic, or how it is going to be friend to us, or how it is going to help us in establishing various biochemical, or I can say that ecological interactions in terms of its balancing of environment. Simply, do we have really a phase where these materials are being exposed? Yes, we have. So starting from its production stage to the consumer they reach, their entry is possible into the various compartments of the environment, starting from the air, water, and also including diet. As a result, at the end of the life cycle, they may reach again into the environment where we are still predicting what is the fate of these compounds and what kind of impacts these materials are going to have on the environment. Still, we are configuring out. So inevitably, action, use, and disposal will lead to the release of these materials into the environment, and wastewater treatment streams and landfill and combustion of products may end up in the environment. Upon entry into the environment, these engineered nanoparticles may remain intact or undergo one of more reactions, such as dissolution may happen, or they may undergo different kinds of speciation. Biological or chemical transformation is possible, and agglomerate, disagglomerate to emerge as some other micro scale products. So thus the nanoscience, starting from its production at a level of the, employed as in R&D scale or large scale commercial production of nanomaterials and their storage processes and also various applications. And at the end of the day, they end up in a wastewater or waste streams where we have to talk about this. What are the implications of the things? Do we really have the implications or not? Are they toxic or not? There's a question we have. And to establish or so as to demonstrate the kind of impacts, do we really have this presence of this environment, presence of these materials in the environment or not? That is a question immediately arises. Yes, they are present. There is evidence of the occurrence of these nanomaterials in the various compartments of environment. For example, the titanium dioxide, which is recently being banned by EU in different applications of the food material production. And zinc oxide, silver, and gold are being detected in various waste streams. So, in a nutshell, human implications include this toxicity, which is still yet to be configured out how it is going to be toxic. Nano-sized materials do not behave like their bulk counterpart. There is a challenge I was talking about, because the moment we miniaturize these materials to their nanomaterial size, the properties are being altered. How these properties are really going to a problematic part, how their interactions is really going to matter, and is really significant or not, still we have to establish the fact and figures, and also we need to build up the database on this line. And reactivity of these nanomaterials due to large surface area and the potential for bioaccumulation really happening or not is another conundrum of the science. And environmental implications, really. So contamination of water and soil from improper disposal of nanomaterials. So if you look at these guidelines as on date, what we have as per the waste management strategies, starting from the like solid waste management, plastic waste management, biomedical waste management, etc. We have this hazardous waste management. But how really we are integrating this emerging contaminants as a part of the dealing the problem. So how we are well placed with the kind of the evolution of the science is happening. Are we really abreast or with the technologies, and also the safety considerations in this area is a big question in front of us in terms of the social dimensions, also at the level of the policymakers. Simple one example I want to tell you is at what level these long-term health impacts are possible. So if I want to recall, if I can recall the context of the pesticide scenario, once upon a time we were saying that no pesticides, chemical pesticides can be applied, and they are very much useful in giving the crop yield, and also they can save us from the protection from the different kinds of pests. But we started employing this technology in a crop, in the agriculture sector. Later on, we also realized that there is one problem called as bioaccumulation, or we can say that these are going to pose a problem on the environmental sentinels, environmental compartments, water treatment systems, or the water, etc., or even soil pollution is possible. But on the other side of the humans, if you take it, through any food chain, or I can say that any chain in which is the ecological systems, whatever the interactions of these nanomaterials, say for example, in this slide, I'm talking about the metals or metalloid, how they are going to cause the imbalance of the health systems. For example, our blood system, pH has about neutrality. How the entry of these nanomaterials is going to cause an imbalance in this homeostasis is explained in this slide. These are going to cause some problematic on the biological processes of these organelles, what I'm showing here. In our cellular systems, nucleus, Golgi apparatus, and molecules such as the proteins, and they are going to be affected by these interactions of these materials, finally leading to the, it may not be immediate reaction, or we can say that immediate result or outcome, what we are going to see in terms of a phenotypic impact, but it definitely have a long-term impacts of the dysfunction of the organs such as the lungs because of the inhalation, and also dysfunction of the organelle system such as the digestive system. Therefore, there is a need for establishing understanding such facts and figures so as to understand how we can combat the impact of such materials is needed. So what we know as on date, so nanomaterial human health risks and risk assessment. So still we are in the process of that unknown exactly what human health and risks of these materials, and we have insufficient data in order to talk about this. Therefore, most of the organizations like say for example, our Department of Science and Technology, Department of Biotechnology, and the Government of India are making their efforts so as to bring this, what are the recent trends and how they can be employed in various sectors. But on the other side of the globe, starting from the US EPA and OECD, are looking at how we can employ the current trends of the assessing the toxicity of these materials, how we can configure about a framework which really address the problem. In this procedure, the one thing I want to bring to your notice is that can we reasonably predict structure and property of these materials when compared to nanomaterials as of now? So still that is a question mark. I can say from my perspective it is no. So absorption properties, distribution properties, and excretion properties, toxicity data, target on organs, and also persistent levels of these compounds in the environment are still yet to be understood. So where are we going? What is? So the lack of reproducibility in toxicology studies is due to there is existence of the or I can say insufficient controls are there. Suitable analytical techniques or softwares, toxicology assays are still in the process of being standardization, and small sample size is being employed in most of the scientifically published studies where we have to come up with some conclusions which are yet to be, again, I can say that demonstrated. And local environment around nanomaterials has a profound impact on them. So we have to establish how these surroundings, or I can say that what are the environmental interactions. Then I can say talk about what are the implications of these materials is one of the important areas for the discussion now. And so far, this important effect has not been addressed in a comprehensive way in most of the investigations. So nanotoxicology is just not a one science. I can say that a physicist, or I can say that an environmental nanoscientist, or I can say that a nanotechnology or another perspective. It's an interdisciplinary approach where we need all the scientists from the different disciplines, not only a scientific phenomenon, social sciences and the policymakers or the policy studies, are to be integrated so as to understand what is the conundrum of these nanomaterials exactly is going to be a problem. Is it a really big problem or not? So it is not to condemn that nanotechnology is bad. No, it is not at all. It is a precautionary principle. Let us understand where is the limit. So to what extent I can allow this technology? So what is its integration with the different other areas of the possible considerations to make a certain policy in terms of its applications as well as implications. So in the era of sustainable development goals, most of us are well versed with the 17 sustainable development goals. We are working on different kinds of indicators, as one of our first speakers were talking about. Are we really marching towards this era? By 2030, we have to meet certain goals. But in this context, just I want to highlight the importance of the understanding of the emerging technologies such as nanotechnology and healthcare technologies, etc. It's not a one goal we are looking at individually, or I can say in isolation. It is the interdisciplinary as well as the among the collaboration of this group of the people who are working for these objectives should be taken into consideration to find out what are the synergies among these goals, and to what extent my nanotechnology is going to enable other goals in this process, and what are the trade-offs of this phenomena are to be discussed, or I can say that are to be documented, so as to come up with a clear-cut annotation of the policy, so that how we can bring out what are the trade-offs and also synergies of the various technologies as a part of the sustainable development goals is one of the needs from the social scientists, so as to understand how the technology is going to really make a significant progress in marching towards our 2030 agenda of these sustainable development goals. So in a nutshell, if I look at a major application of these nanomaterials in terms of the pesticides, so we are formulating nanomaterials in terms of the pesticides and fertilizers, and also we are developing the various nano sensors based on the food safety purpose, and also we are bringing about various technologies for the food packaging materials, food transportation system, and also we have the different kinds of applications. Well, it's very appreciated. But are we really in a position to address safety and challenges of these materials, how these materials are going to enter into the environment, and what are their impacts on various compartments of the environment, say for example, aquatic environment or air and soil environment? What is the amount of these substances as on date, whether it is released into the environment, are really still in the naive form of the nanomaterials, or still they have or emerging as a bulk counterparts, so therefore there is no harm. So we are in the process of this decoding the language of these nanomaterials at the end of their life cycle. In this context, as a part of my research at BITS Pilani, so I try to understand or try to address some of the questions of this area. My research addressed as a part of this, really these nanomaterials enter into environment or not. So I studied as a part of my thesis, this and research work, I say that these nanomaterials enter the environment, there is a possibility. So I detected nanomaterials, say class titanium dioxide nanomaterials in wastewater treatment systems. And this data is very useful in conducting toxicity assessment studies. This is one of the techniques I employed in, this is a technology background. I don't want to give much on the highlight on the, because it's called a single particle ICP-MS. That is a single particle inductively coupled plasma mass spectrometry, which detects the signals of these nanomaterials that are present in the wastewater on sludge. So that is how I detected this presence of these nanomaterials in the wastewater. And as I was talking about, do the environmental factors matters in how they determine the fate of these nanomaterials? So I was trying to establish the fact that really the electrolytes, compounds, and the dissolved organic matter really have the implications on this behavior of nanomaterials. Was also studied. Yes, they have the implications on these nanomaterials. Therefore, the surrounding environment plays a very crucial role. Therefore, I proceeded to understand this toxicity of these nanomaterials of titanium dioxide and what is a possibility of their impact on the environmental sentinels such as earthworm. And I studied what are the markers. The marker is an indicator. So at cellular level, do they really pose a problem or not? Yes. So this is a technique called as a proteomics. That is a proteomic profiling, where nanomaterials are being studied for their end impact in a cellular interaction. It's an overall integration of what kind of proteins are being impacted if it is exposed to nanomaterial, if it is not exposed to nanomaterial. If it is exposed to nanomaterials, major functions such as ATP binding and contraction of the gut, cell division properties, and toxicity from the different kinds of substances, metal binding properties and protein folding properties at a cellular level, at organism level are being impacted by these nanomaterials. Therefore, it is very essential to understand subcellular markers so as to give what are the long-term impacts possible because of this exposure of these nanomaterials. So my study contributed to understanding the designing of the study so as to talk about how the current methods of the OECD can be used so as to assess the toxicity of TiO2 materials, and how we can employ these called as proteomics, omics technologies are really important in understanding subcellular level markers so as to propose the long-term impacts of these materials. So in recent updates, you can see that how the titanium dioxide is being recommended by EU plants. You can see that EU plants ban on titanium dioxide in food. What are the factors they have noted in this context is that there is uncertainty about this molecule that is material that is a E171s. Its ability to accumulate in the body and damage genetic material in cells, that is called as a genotoxicity. And also the agency could not calculate on acceptable daily intake. So we are still in the process of unable to find out what exactly, where it is going to cause problem. So these kind of regulations are emerging, and we need to understand the conundrum of this kind of recommendations and to what extent is going to be safe or unsafe, or can be recommend or not recommend by the policymakers to be done. So in conclusion, I can say that there are limitations related to the what exactly qualifies to the nano waste. I've been talking about the nano materials, but what exactly the nano waste? Still, we need to configure out what it's just a combination of the different kinds of nanomaterials at the end of a life cycle, or what is it? So it can be called as hazardous waste or not, and triggered by the threshold values not tailored to the nanoscale. So we have threshold values defined by the regulatory agencies. So we have the legislation in place for various kinds of the hazardous substances. Do we really understand what exactly the application of this existing scenario of the hazardous waste management rules to the nanomaterials? We have not yet given that classification. Still, the organizations like registration, evaluation, authorization, and restriction of the chemical reach is configuring out in association with the US EPA, OECD, etc. And there is a lack of characterization tools, ecotoxicological data, and also occupational environmental exposure limits of these materials. Still, that data is to be given for these kind of materials. I'm not saying that it doesn't exist, but we need to strengthen that line. And the majority of existing nanomaterials and newly developed nano-labeled products have the possibility, or they have the potential to pose environmental as well as the human health impacts. And what level and what concentration and in which form they are dangerous, or I can say they are toxic, we need to predict. And we have so many, or I can say unanswered questions regarding what are the possible hazards. If I take a compound X, say nano titanium dioxide, what is the problem? Do we really have that list? Or what is its lifespan or half-life? Where it does stand? So what is the fate of these materials once it starts from entering from the manufacturing to the end of life cycle in the environment? Do we have such kind of comprehensive assessment and understanding? We need to find out. So nano waste classification and management programs, there is some new challenge and limitations in dealing with how we are handling, how we are treating this, and what is the process in place for the recycling and recovery of those developed nanomaterials from nano waste streams are to be integrated as a part of the circular economy. So we are talking about much on circular economy nowadays, but what exactly, how to integrate these emerging technologies as a part of this, still a limitation. And the last and important point is that we need a current legislative framework. Exactly, we have the real framework exists in Indian scenario or any other country. We need to bring up, and also we need to strengthen by taking the inputs not only from a scientific perspective that I did some technological considerations, or I invented some technological considerations, I did some evaluations. No, it has to be an interdisciplinary approach by bringing all the stakeholders into one platform so as to promote what exactly this waste management paradigm pertaining to the nanotechnology. Are we really going to be promote this safety of the nanotechnology or not, are to be substantiated. Therefore, environmental nanotechnology or the nanotechnology has the great potential to address various challenges, but there is a need for multidisciplinary understanding of chemistry, physics, biology, and other fields, including social scientists, to paraphrase their impacts on the environment And fusion of these disciplines is a major beneficial transformation of the field is to be expected there by meeting these various targets of the waste management and risk assessment. So I acknowledge, I'm thankful for the Pallas Rujuna and also ISSA. I'm sorry, I forgot this, ISSA for giving this opportunity. Also Water and Waste Management, EPTR and my previous affiliations. And in conclusion, I say that art is I, science is we. So science is built up with the facts as a house is with the stones, but a collection of facts is no more a science than a heap of stones is a house. So therefore, I take this opportunity to give this a mere emerging of a technology or designing a technology is not sufficient. So we have to understand the pros and cons and so as to promote the safety of the technology such as nanotechnology. So thank you one and all for giving me this opportunity to share my knowledge in this area. Thank you.
Thank you very much, Dr. Shiva Prasad. Very eloquent rendition of nano waste. I have, I think, few billions of nanoparticles. I don't know how many are really causing problem to me. But I think you have covered totally about what the status today, what they can do, and what the regulation required, what efforts are being done. And I think you have enlightened us that it's also areas, a potential threat to the health of the people. And it
Yes.
needs as much urgency as you brought out. Thank you
Yes.
very much. A layman like me has got, now I can talk about NM quoting Dr. Shahzad. Thank you very much for your time.
Yeah.
Okay.
I have a question.
Yeah.
Over to you.
Yes.
Can you, will you stop sharing, Dr. Prasad?
Yeah, I'm sure. Stop.
It was great to hear you talk about the engineered nanoparticles for effective management of nano waste, sir. So thank you so much for your valuable information on that. Now I would like
Can I put my presentation now?
Yes, sir, you
Hello.
can.
Yeah, please. Please see whether I'm able to, you are able to see?
Yes, sir, 1 minute.
Otherwise, I will close it.
We are not able to see it, sir.
You're audible? I'm audible?
You are audible, sir, but your screen is not to be seen.
Not to be seen till now. Till now. What is the problem?
You need some young people's help, I think. All old people like us
No,
need some
otherwise,
help.
Gandhi Sahib, you transfer the slides to them so that the host will present.
Okay.
Slides.
How I do it? How I do it?
You
You
send your slides
transfer
to
the
me.
slides to a host. They will
Send it
share.
to me. Send it to me.
Yeah.
Ganesh,
Yeah,
you have my email ID with you.
Your email ID, can I have it, sir?
Yeah, it's already there. In the morning, I sent a mail to you yesterday.
Okay. No, I will try. I will do it.
Will kindly invite Dr. Anita.
Yes, sir.
And yeah, meanwhile, you prepare Gandhi Sahib.
ठीक है, I do it.
So I would now like to invite Dr. Anita, who has received MD in Preventive and Social Medicine from St. John's Medical College and Masters in Public Health from University of South Florida. She is currently a faculty member at the School of Medical Sciences, University of Hyderabad since 2014. She is having 19 years of experience in diverse areas of public health such as infectious disease, women, work and development, food safety and security. She has trained mid-career professionals, doctors, nurses, community health workers in public health management, and mentored medical and nursing interns, graduate students, and scholars in public health. She has provided technical assistance and supervised the UNICEF-funded operationalization of maternal death review in state of Andhra Pradesh. She was in an evaluation team assessing the Rajiv Gandhi Community Health Insurance Scheme Arogyashree in Andhra Pradesh. She has also led the clinical component of integrated biological and behavioral surveillance in 5 districts of Karnataka under the Ahvan India project funded by the Bill and Melinda Gates Foundation. She has also been awarded the Indo-US Scientific and Technology Forum Research Fellowship by the Department of Science and Technology, Government of India 2013 to 14. She is a recipient of Partial Scholarship Award by Royal Society for Public Health to present her work in food safety at the Food Safety Management Conference. Over to you, ma'am, for addressing the session.
చాలు పెడితే మెంతమంది పోసేసి చెప్పేసి
Am I audible?
You are audible now.
Okay, I'm trying to share the slides. I hope I'm also not facing the same issues.
Yeah, we will see.
Uh, Actually, I have shared the slides with one of my colleagues. Can I request him can I request Dr. Mahadev Kalyankar to share the slides?
Yeah, ma'am, you can.
Yeah, just give me a second. Let me download. Do you see the screen?
Not yet, sir.
Now do you see?
Yeah, we can see it now.
Okay. Yeah, go ahead.
Yeah, great. Can you make it as a slideshow, please?
I think this is how is it? Is it okay?
Yeah, this is fine. This should be fine. Well, next slide. Thank you, Dr. Mahadev, and I'm sorry. Yeah, actually, it becomes a very huge challenge for me to follow all the stalwarts who have been speaking about the industrial pollutants all this while. So I hope I'm able to do justice. At the outset, I would like to thank the organizers for having me here to present whatever little I know about the industrial pollutants and its effects on health. And as rightly pointed out by earlier speakers, it's true that the industries are the major pollutants, and among the man-made pollutants, industries stand number one. And if you look at the distribution of pollutants as a result of industries, manufacturing sector takes the first place, followed by electricity generation, and then agriculture, if you look at it as an industry, followed by transportation and domestic related pollutants. So manufacturing is where the focus of all the pollutants is happening, and I would like to focus more on that kind of pollution. Next slide. Energy generation is one of the major things, as rightly pointed out, and coal power plants are very many in our country. And if you look at the Indo-Gangetic plain, there are many electricity generation plants which are dependent on coal, and because of the presence of the Great Himalayas and the southeastern winds which flow towards that side, the region of the central India, especially Delhi and all, they experience this huge pollution, which leads to all the pollutants staying at the ground level during winter season. And there are a lot of exaggeration of health related events which take place around that time. And if you look at the map of our country, nearly 55% of India's coal-generated electricity is within 500 kilometers of 5 megacities, and these are Delhi, Chennai, Mumbai, Bangalore, and Kolkata. And the urban residents are hugely dependent on this, and they cannot even tolerate a 5-minute loss of power or electricity. And rightly so, because the way we are going, we do not want interrupted power supply. It could be in factories, it could be in hospital care settings, or in educational institutes, or so many other places where continuous electricity supply is required. And there are certain specific groups also which are vulnerable, and I will come to that subsequently. The other industry which I really would like to highlight is the chemicals industry. And as Dr. Baburao was correctly pointing out, they want to increase the output of all the products arising in the industry so that we can have this GDP growth. And you will be surprised to know that India has got 80,000 commercially available products. These are chemical products, and they come from diverse fields like bulk chemicals, specialty chemicals, agrochemicals, petrochemicals, and polymers and fertilizers. So when it comes to the domestic market of chemicals in India, there are small, medium enterprises, and they are expected to showcase 18 to 23% of revenue growth in this financial year. And because of both domestic demand as well as the high cost of these chemicals, the profits are bound to come through. And India's proximity to the Middle East, which is the world's source of petrochemicals feedstock, that is bound to enable this growth path. And we stand to gain in terms of several billion of US dollars, 178 billion of US dollars, and this was the case in 2019, and it is going to go up in the year to come, and it's going to go up at the rate of 9.3%, and the demand is going to increase by 2025. And the chemical industry is expected to contribute nearly 300 billion US dollars to India's GDP by 2025. So we have to make some investments, but investments are minimal when compared to what damage it's going to cause to the environment. And also we have to think in terms of what it does to the health of the people, animals, and the flora and fauna in the environment. Next slide, please. The chemical industry, again, the pharma industry is one of them. Nearly 20% of the exports are happening from Hyderabad. And we know very well that the chief minister is very keen on getting pharma city in Hyderabad. It is already existing and they want to expand the same. Nearly 1/3 of pharma production is from Telangana, and 412 pharma companies were manufacturing 173 bulk drugs. And then United Andhra Pradesh had around 566 pharma companies, and this has certainly gone up even in the independent state of Telangana. So the total pharma industry national sales accounts to 210,600 odd crores worth of rupees, and this is much before the pandemic. And as you all know, the sale of Dolo itself has gone high, and if you put all those Dolos which have been sold, you can make the heap of it is equated to even higher than the Himalayas. So you can imagine how much drug is being consumed by the general population, as well as the stress on manufacturing, and where exactly is this manufacturing waste going on. Next slide, please. So most of the industries are located in Rangareddy district, and it has around 31 industrial parks. And the merchandise exports from Telangana is worth up to 12,837 crores. And the organic chemicals too comprise about 33.23%. And recently, the Telangana Socioeconomic Survey in 2015 identified industrial pollution, groundwater pollution as an important factor which has to receive concern from the authorities. And according to the very recent dynamic groundwater resources of Telangana state, Hyderabad is the only district in the state that has been categorized as critical for groundwater. I'm sure this will get expanded to other surrounding districts if the pandemic is over and all the factories get functional in full capacity. So the pharma industry is responsible for morbidity and mortality. I say this because generally for curing the disease, we need pharma industry. But over a period of time in Hyderabad itself, the kind of harm it has done to the people, to the environment, it has led to a lot of morbidity and mortality. This antimicrobial resistance is another major concern, and it is rising. And this happens when people are taking drugs at their own will without consultation and by not completing the course. More than humans contributing to this, the antibiotics used in the feed in the livestock industry and in agriculture, that has led to resistance, followed by, of course, human behavior. And also, we should remember the fact that whatever waste is generated both by humans and animals, and when they throw out these antibiotics, uh, there is this lateral gene transfer kind of phenomenon happening. And when these organisms are in the sewage tank treatment plants, there is this resistance which is developing to these antibiotics. Although they claim that there will be local employment generated for the people, the benefits and risks, if you calculate, the risks outweigh the benefits, especially for the local people. Of course, it is promoting global trade, but the first world countries are always safe, and they want the drugs to be manufactured in third world countries, and they keep their environment and people safe, and reap the benefits of the cheap labor which is present in the third world country. And they in fact impose the carbon footprint, the whatever punishment you say, to the third world nations. And because of these meager job opportunities which the industries offer, there's a lot of migration, especially from rural area to the urban area. And in the last 2 decades, if you look at migration in India, it has not happened from India to countries abroad, but it has happened from rural to urban area. Hence, you see this growth of metropolitan cities at the rate which they have grown. Next slide, please. So I would like to talk about the leading killers of, the leading diseases which kill humans in India. And it's no surprise that heart diseases are in the top list of top 10 since 2012. And chronic obstructive pulmonary disease, which is as a result of, air pollution or the respiratory systems condition in individuals, that tops second, and third is stroke, followed by diarrheal diseases. And if you look at lower respiratory tract infections, that's come down, and that's related to maternal and child health, they are going down. That's related to communicable diseases is going down. But non-communicable disease is coming up. This is a slide which talks about the global burden of disease, and I specifically looked for India. And if you look at the green dot, it speaks about the environmental and occupational risks, and the purple dot stands for diet or nutrition related things, and the so-called orange dot, it looks in terms of metabolic risks. So if you compare from 2009 to 2019, for which we have the latest figures, malnutrition continues to stand on top, followed by air pollution, which stands at second place. That means for last 1 decade, we have not done anything about air pollution. It is stagnant. We have not done anything about malnutrition. And there are other things like only thing which has seen a drastic fall is the water sanitation and hygiene. And in COVID times, I think that has done even better because of the the information, education, and communication which was translated to all people for preventing the spread of COVID-19 further. So next slide. When we talk about air pollution and other pollutants, there are routes of exposure in humans. And for this audience, learned audience, I need not say much, but for the sake of completion, the air through lungs enters our bloodstream, and the polluted water enters through either contact with skin or the gastrointestinal tract. food and water comes through the same route, and also there could be some entry into our system through soil. Next slide, please. So all these pathways actually, they ultimately come to the human receptor. It could be directly, or it could be because of indirect entry. Air pollutants are one which directly enter into our lungs, and since the blood is purified in the lung, all the pollutants directly enter into the bloodstream, and that's where they clog the arteries, and hence recently they have found that cancer, stroke, and ischemic heart disease has the origins because of air pollution. Next slide. Here, I would like to show the interaction of environment with our body organs. And I have taken three main organs which act as a barrier to the external environment and to the internal environment. If you look at lungs, the previous slide, please. Yeah, the area it covers is 140 meters square, and it has a thickness of about 0.2 to 0.4. It varies in different regions, and the whole of the lungs weigh less than 1 kilogram. It ranges between 0.8 to 0.9 grams, and the daily exposure to the air through lungs where we breathe, we require 24 kgs of air every single day. And when compared to skin and GI tract, you can see why the lungs or the respiratory tract is so vulnerable. Next slide, please. So this is the respiratory tract, and there are pollutants in the air like particulate matter and other pollutants which enter into the alveoli sac if the particulate matter is too small. When I say too very small, it is 2.5 millimeters. And there are other particulate matter which are about 10 mm, and I say these two diameters because this is what they monitor through our air pollution control. And the main air pollutants are particulate matter 2.5 or 10, then oxides of nitrogen, oxides of sulfur, ozone layer, carbon monoxide, and ammonia. Ammonia is added especially in India. Next slide. So this is certainly a public health concern for us all, and you know very well that we are not breathing healthy air, and our generations who are to come next, they are also not going to be left behind with clean air. So it's proven by reducing particulate matter pollution from 70 to 20 micrograms per cubic meter, we can cut air quality related deaths by around 15%, which is quite huge. And the global burden of disease from respiratory infections, heart disease, and lung cancer can be reduced. And we will cut emissions of gases contributing to climate change and also provide other health benefits. Next slide. This is the typical air quality index. If you're listening to the news every day, you will invariably see that the air quality index is going poor and worse. And it also varies from place to place. There are certain points where the air quality index is monitored. And India sadly has got very few number of these sites. And anything after the orange indicator, it has to be a matter of concern. That is, after 100, it is a matter of concern. And if the numerical value of air quality index is above 200, then it becomes very unhealthy and at times hazardous. Again, I'd like to reiterate here that old people, children, pregnant women, immunocompromised people, they are more vulnerable to these numerical values. Even at lower values, they can experience high distress on the respiratory system. So the health impact in terms of actual signs and symptoms, for particle pollution, irritation of the eye is common. Then there is irritation of nose, throat. It can result in coughing, phlegm formation, tightness of the chest, and shortness of breath, and it is known to cause morbidity and mortality. So reducing particulate matter being released in the open is very important. And toxic gases and fires too have this particulate matter, and They contribute to acute and chronic respiratory illness, and evidence suggests transboundary impacts. For example, the fire in Indonesia, it can have its impact in another country. And the studies have indicated that such a thing has happened in the past. And wind-blown dust from desert region can affect populations in remote areas. And I would also like to touch upon the ozone pollution, which is like it can cause pneumonia, lung irritation, inflammation of the lung lining, reduced lung function, aggravation of asthma, chronic bronchitis, allergic rhinitis, and they're also susceptible to infections and other premature mortality. A word of caution with regard to exercise also, when the air pollution is very bad or too poor a quality, exercise and activity outdoors should not be undertaken, as it can aggravate the health effects, because we breathe more and what we are breathing is poorly oxygenated air. So the pollutants are going on. So as I mentioned, the at-risk groups are children and older people. And precautions when the air quality index is bad is to use the N95 mask. The N stands for not resistant to oil, and 95 stands for removes 95% of the particles, dust particles, which are less, except those which are 0.3 micron in diameter. Next slide. So literally air pollution kills. There are class 1 carcinogens present known to cause lung cancer, and these are due to asbestos, arsenic, and tobacco. It also includes some of the diesel emissions. And air pollution is one of the top 10 killers, as I alluded to it earlier. And the International Agency for Research on Cancer, it has said there's definite link to cancer and air pollution. So in a very high number of Asian cities, like in Karachi, New Delhi, Kathmandu, and Beijing, and in Latin America, in Lima, and in Africa, in Cairo, all these places exhibit huge levels of unacceptable levels of air pollution. The health effects, even if in relatively cleaner cities of Europe and North America, even if they claim that we are cleaner when compared to Asian and African cities, they do have reports of adverse impact of air pollution and increased cases of lung cancers. So every organ is affected because of this poor air pollution, and I have put the pictures and how it impacts. Next slide, please. So when we talk about industrialization, we can't be without talking about urbanization. And we have this plan for every district, and they say that this district should manufacture mineral cement and food processing. You have another belt, another district which should manufacture chemicals and automobiles and pharma, another district, so on and so forth. But no plan talks about how to control the waste generated, or how to punish the highly polluting industries, what restrictions is to be put, at what frequency they have to be monitored, and also they're literally going scot-free. As indicated, we are looking for profits, but we are not looking at the harm done to the environment. Next slide. So in India, if you look, because of industrialization, there is migration, of course, and this migration has given rise to poor housing conditions, and poor housing conditions have an impact on health. So next slide. So substandard housing can result in spread of infectious disease. Dharavi was a classic example for COVID-19, and subsequently, yes, of course, it was controlled. And then the spread of respiratory infections are very common if the places are overcrowded. And also they have exposure to extreme of cold conditions, extreme cold and heat, and this is not good. Poisoning and injuries are quite common if the housing standards are substandard. Next slide. Okay, so Michael Mudd, who was heading the Commission for Social Determinants of Health, he said that These are non-medical factors that influence health outcomes, and these factors are the conditions in which people are born, grow, work, live, and age. And the wider set of forces and systems shape the conditions of daily life. So these forces and systems include economic policies and systems, development agendas, social norms, social policies, and also political systems. So we have to focus on these things. So we can skip this because I've covered the environmental risk factors. Again, we can skip this because I've covered it. So some of the diseases linked to degraded environment are air and water pollution, and it continues to affect people in India, even as per the recent National Health Report. And air pollution linked acute respiratory infections contributed to around 68.47% of morbidity burden in the country, and also the highest mortality rate after pneumonia. Acute diarrheal diseases caused due to drinking water contamination is the second highest morbidity at 21.83%. Look at the gap between air pollution and the water related diarrheal disease. So air pollution really stands out at 68.47%. Cholera is another disease which is waterborne, and even today in states like UP, Delhi, and West Bengal, typhoid cases are going up. And of course, there is vector-borne diseases which are increasing again due to the stagnant water conditions, and they contribute to high mortality and morbidity. So the natural environment, which is like air pollution, water pollution, and noise pollution, do contribute to the ill health. I would like to focus here on the noise pollution. It's recently come to light that the mental health, risk of dementia, and some of the heart conditions are associated with noise pollutions above 85 decibels. If continuous exposure is there, there will be anxiety, palpitation, and the heart conditions definitely one can expect. So public health is all about preventing the disease rather than prevention is better than cure. That's the mantra on which it operates. Next slide. Next slide. So there are pollution control measures in the factories which are set up. So every industry, the wastewater purification, material recovery, waste storage, arresting of toxic gases, these are there in black and white. And the availability of common effluent treatment plant, which is happening in the GD Matla plant because of the outrage of the public in Patancharu Bola Aram industrial area. That is also available. And transportation through the tanker vehicles, all these things, the effluents are taken in these tankers, and pipelines are also set up. But these are all containment aspects which are there in place. In the first place, they are not preventing the pollution which can come to the environment. Next slide. So as expected, curbing air pollution remains the key focus. Strengthening climate adaptation measures is important. Health infrastructure to deal with the impact of climate change has to be addressed. Right now, we do not have a proper health infrastructure, and COVID-19 pandemic put it all in the bare open that we really lack basic health infrastructure. And we have to also ensure the ban of plastics, because plastics are another menace, especially in oceans where it gets dumped ultimately, or in the ground, in the landfills where it intoxicates the soil. The policies in environment should actually integrate the health impact of air pollution. Any polluting plant to be subjected to what is called as health impact assessment. Even before the industry comes in, this has to be subjected. We have a national clean air program. It it was launched in 2019. It has not really taken off because of the pandemic, I would say. Next slide. So the issues in air pollution control, actually, the coal-based power stations are the main culprits, and all of them are spread across different states, and they have to be critically monitored, which is right now questionable. Next slide. Again, from integrated steel plants, there is this air pollution, and states like Orissa, Chhattisgarh, and Jharkhand, they are into this iron ore mining, and they are the most polluted states. And even the health, if you compare, it is very poor in these three states. So you have other air pollutants like vehicular emission, but this is next only to manufacturing and electricity generation. So now we have the solid waste, which has to be generated in the which has to be managed in this so-called mega cities, and that again is a challenge. Now, for air quality measurements, we need institutional mechanism, we need coordination and information flow with different state departments and also the central department. And this, to this day, is very weak and it needs strengthening. Air quality monitoring, again, the data is not verified, it's not compiled or collated. And any emission inventory which has to be maintained, it is not existing as on today. And source apportionment study, it's not conducted. Training of personnel is not adequate, and chemical profiles do not exist. One of the things which happened during the Bhopal gas tragedy is when the gas leak happened, the treating doctors didn't know which was the gas leak which came and which is the antidote for that particular gas. And despite such a huge tragedy which happened in our own country, we are not prepared for these kind of accidents, industrial accidents even today. The health impact study, few epidemiological studies have been conducted, but no regular data collection is happening in the hospitals. Next slide. So these are the breakpoints for pollutants as per the Central Pollution Control Board in India. And you will see that once it starts becoming poor, it is really not breathable or livable. And there are 8 pollutants which are monitored continuously. And some are done on a daily basis, some on a weekly basis. So in order to improve the outcome of this air pollution, we need to improve our healthcare services also. And policy making is one of the important things. And any environmental policy should incorporate the impact on health. There have to be health programs, both at national level, global level, state level, which incorporates, controlling air pollution, which is currently not available. Health awareness, particularly of air pollution, it has to be told. These days, this education is happening in school, but school children are not sitting in the decision-making bodies or the profit-making bodies. There has to be upliftment of primary health centers and enhancement of research activities in medical institutes and even in other universities. Increase in manpower, that is in terms of healthcare professionals to deal with this air pollution related illnesses is important, and increased accessibility of healthcare services to all people is essential. And the goals within the Sustainable Development Goal to ensure healthy lives and promote well-being for all at all ages is important. So if we strive towards decreasing air pollution and also by improving healthcare, we can achieve some of the sustainable development goals which is mentioned. And I stress again that we are in emergency zone already. It's not that air pollution emergency is going to come. We are in it. We are breathing. We are in this chemical cartel. And it's time to act now. And with this, I'd like to stop my presentation. And if there are any questions, I'd like to take. And I'm sorry if I've rushed for want of time. Thank you, Dr. Mahadev.
Thank you, Dr. Anita, and thank you, Dr. Mahadev, for helping and showing the slides. I think you have a bit scared us, but you told the fact in terms of industry. You know, we are getting a positive spiral in the negative sense. Now, you have industry, the growth is important, then the health goes bad, then pharma industry goes up because they get more demand. and then the whole thing getting into a positive spiral in the negative sense. Somewhere we have to draw a line about growth rate, year on year or quarter on quarter growth rate. I hope it's a social political consensus one has developed. And thanks a lot for your insights you have shared with us. Right? Thank you. Let's complete with the two more speakers. Then I think if any questions we can do, it's already getting late. So Prerna, over to you.
Thank you, ma'am, for sharing your views on impact of industries on environment, energy, and health. I would now like to invite Dr. M.V. Jagannathan, who has trained several students from BTech, MTech, and MSc in proteomics. He has guided several students in their PhD projects and conducted several workshops on proteomics. He has been awarded fellowship under CSIR DAAD Scientist Exchange Program 2010 and has visited the laboratory of Dr. Hans-Peter Grossart, Leibniz Institute of Freshwater Ecology and Inland Fisheries. He has also received eminent mass Spectrometrist Award from Indian Society for Mass Spectrometry in 2015. He has also been presented Bharat Jyoti Award in 2014 and has received Bharat Vikas Award from Institute of Self-Reliance, Bhubaneswar in 2018. He has been awarded with Outstanding Scientist Travel Award to attend the annual meeting of the Association of the Biomolecular Resource Facilities 2019 held at San Antonio, Texas. He is currently teaching and doing his research work on structural and functional studies of membrane vesicles from bacteria. Over to you, sir.
I am trying to share my screen. Is it visible to all?
Yes, sir, it is visible.
Just 1 minute, I have to increase the size of the screen. Yeah, good afternoon to all of you. First of all, I would like to thank Brigadier Ganesham and Sri Kocharlakota Murthy Garu for providing me an opportunity to come and interact with you and make the presentation today. And indeed, I am very happy to be associated with Indian Social Science Congress, which is a precursor of that particular meeting. Now I would right away start with my talk. Today I am going to talk to you on COVID-19, the virus and the vaccination. We are now in the middle of the pandemic. So it is coming in new variants and different avatars. And each time it comes into a different shape. It is acquiring new properties and throwing a challenge both to the researchers and as well as to the doctors and the public health system on how to contain this particular virus. But we have been acquiring a great amount of success so far with the experience of the last 2 years. But still, a lot more need to be done to understand this virus and its biology and to contain it more effectively. Before entering into the talk, I would like to just give a brief introduction because now this coronavirus has become a public talk and a basic biology of this will give us more understanding on what we have been talking all through. Actually, our biological cells will have DNA, RNA, and proteins. In fact, all life forms on Earth. If you take animal, bacteria, plant, humans, anything, the basic fundamental molecules of life are DNA, RNA, proteins, lipids, and carbohydrates. And this DNA, which contains the genome, that is called the complete genome of a particular species. And from DNA, RNA is produced. From DNA, RNA is produced. And this RNA will have the information on what protein to be made. And that proteins are made, and proteins are the functional units within the biological systems. And also it has the capacity to make lipids also. Lipids are the walls. You know, like 4 walls we have in the house, cell also has a wall, and that cell, this wall is lipids. And all these proteins, RNA, carbohydrates, nucleus, all the molecules are contained in that bag of lipids. So there, all the biological reactions takes place. When we look at the structure of DNA, most of them are aware of this one, or generally, it is the double helical structure of the DNA, which is proposed by Watson and Crick. And this contain a pair of nucleotides, this DNA structure, AT and GC. These alphabets, they are given with adenosine, thymine, guanine, and cytosine. So this pairing up of is very specific, and that is how they pair up. And this pair is like a distorted ladder, and that is the complete genome. The complete genome is with this particular structure. And this is the structure of RNAs. The only difference between DNA and RNA is RNA has a uracil, and this will not be there in the nucleotide, but this is more of a linear kind of a structure, generally speaking. And from DNA, RNA is produced. And these are the basic differences. DNA contains thymine, whereas in RNA, it is uracil. So that is the only difference. But these molecules will perform a lot of biological actions. This is the general activity of a cell. If we have a biological cell, the entire genome is in the middle of the cell, and that program will give what transcribes. This process of formation of RNA is called transcription. So it transcribes into RNA, and that RNA translates into protein, and these proteins, and these are the genes. This is distorted structure of the ladder, what I am talking to you. And some portions of this are called genes. Generally speaking, some portions of these genes, and they say how many proteins can be expressed in a genome, and these proteins will function either independently or as complexes. So this is the general biology for whatever we take. So this is the same thing that I am representing again from genome to, and then come to what is a virus. Virus is not a life form. This is neither a life nor non-life. It is in between. It is a submicroscopic infectious agent that replicates inside the living cell of all life forms. It can be a plant, an animal, or a human. And that is why they are parasites. A virus cannot multiply itself if you put it in a test tube, or if it is there intact on its own. Unlike the other microorganisms like bacteria, a bacteria produces another bacteria, an animal produces another animal, a plant produces through seeds or other process another plant, humans produce, but virus cannot produce itself on its own unless it has a host. That host can be a plant, animal, or human. So this is virus. Usually these viruses are DNA or RNA viruses. This is generally speaking. I am categorizing because the virus that we are now suffering with is an RNA virus, and they are surrounded by a protein of the same gene that they contains. So this is the structure of the coronavirus that we are talking about today. So inside the middle, that means if this is like a ball, and these spikes that are showing, and which we generally are calling this one is a spike protein. This is a spike protein, and if you cut it into two pieces in the middle, it is like a ball. You can see the nucleic acid. This mRNA is inside, This is the mRNA that is inside the virus. So this is the genome of the virus. This is what we are trying to sequence this entire genome. Then we know the structure of this entire genome of this virus. And this virus produces not only spike protein, it will have several other proteins like membrane protein or nuclear capsid protein. So other non-structural proteins. So it produces this mRNA, what it contains, can produce large number of proteins. That is 17 to 18 proteins that it produces generally. And more structurally, these are the important ones which involved in the activity of this entire virus. So then, how it is entering and infecting the cells? The biology remains the same. What I told you, there is a DNA, but now this virus is an RNA virus. So there is no DNA. Directly, it has a functional unit, transcribed form, and this virus enters into our biological cells, and it takes control of the transcription or the machinery that produces these particles in the biological cell, and then multiplies itself. How it enters? The biological cell that we have inside should contain an ACE2 receptor. So that means this virus particle can infect only those cells which have these ACE2 receptors. So that this is the door which opens for the virus. Other cells does not open. That is why this lungs, respiratory tract, these are the places where it is infecting the most, where we have a lot of ACE2 receptors. So it takes control of the host machinery of the translation. That means making the RNA, making RNA and making RNA into protein and packaging again into a virus. I will show you in a cartonic picture in a short period, and produces its own copies in large numbers. So this is the cartonic picture. These are the earlier versions of this coronavirus. This is SARS-CoV-1, earlier it has come, and MERS-CoV, Middle East Respiratory Syndrome, severe acute respiratory syndrome. These are the SARS, severe acute respiratory syndrome is for the coronavirus. Similarly, we have another virus which came earlier called MERS, Middle East Respiratory Syndrome. And now the new virus that we are talking about, COVID-19, this is SARS-CoV-2, severe acute respiratory syndrome, COVID-2. And that is also called COVID-19 because it is 2019. It started from Wuhan. So this label of 19 was given to it. How these three viruses have the same mechanism of entering into the cell. So they come in contact with the ACE2 receptor here. You see, here this is the ACE2 receptor. And then through ACE2 receptor, it enters into the cell. And in the cell, it goes and then take control of this machinery and start producing the RNA. And this RNA, I told you, from RNA, it produces the protein. So whatever the coding that it contains, all the proteins is synthesized. And now they can again package here itself. That means the RNA that is produced and the proteins that are synthesized in the cell are packaged and multiply their virus particles, and they come out and then infect the other cells. So this is how the multiplication of this virus happens in the cells, and they produce in larger numbers. As the virus produces in large quantities, slowly the symptoms keeps appearing for the infected person. A virus keeps increasing, symptoms start appearing like cough, breathing trouble, and so on. Finally, destroy the organs also, lungs. We have seen in the second phase and the first phase where there are a lot of deaths due to this infection of the lungs, and it creates a severe, this one and a severity, and including deaths to the individuals. So therefore, what happens when a virus particle attacks our body? This is an important question. Does our body keep quiet if a foreign virus particle attacks us? The answer is no. When a virus particle attacks our body senses this virus particle, and as a first line of defense, that is the fever. When it increases the temperature of the body, that means the body feels that by increasing the temperature, it can somehow denature or inactivate the virus. If it can do so, it is asymptotic or even slightly mild, those cases. So that means our body has taken care of that in the beginning itself. But if the body is not able to fight that, then our body go to the second line of defense and it starts producing the antibodies. And then these antibodies also tries to fight against the virus. And the immunity that we have, called innate immunity, plus the immunity that is produced by the attack of the virus, these two coupled together also are unable to fight the virus. Then it starts infecting large number of viruses. So virus has gained more power than our body, and it starts creating these symptoms like fever and infection of various cell types, and ultimately leading to death or infection. So our entire process in this, if we see, where we can take control of this at these various stages. How to control this? So we have to have several measures. So in this, what happens, innate immunity and also acquired immunity, if both are not able to take control of the virus, then ultimately virus takes control. And in some cases, ultimately with these clinical interventions, we will be able to save the people, or in some cases we have lost a lot of people where we have not even able to save the people. So how to do this? And how a vaccination works? What is vaccination? And what does vaccination works? Vaccination is a process which gives you the same kind of immunity like a natural infection. Per se, generally, there is no difference between an infection and a vaccination. But the main difference between these two, in the vaccination, we inject an inactivated virus. So therefore, it enters into our body and it does not have the activity. Whereas a virus which is active can reproduce itself and elicit all those reactions. Whereas a vaccine is also a foreign body, which is an inactivated virus, that means the same form, inactivated form injected, then our body responds in the same way and produces antibodies. So therefore, vaccination is a preventive medicine. Vaccination is a preventive medicine. Therefore, we have to give vaccine before the people can get infected or before they spread the virus. Now, in this kind of a pandemic situation, what happens? One person can infect multiple people because this virus goes through air. This goes through aerosols. So when we speak, when we breathe, or when we talk, at any of these activities, the virus particle comes out of our mouth, nose, and therefore that is why it is suggested to use a mask. And they can travel through 2 meters distance. So that is why they said a physical distance of minimum 2 meters you keep in the social distancing or a physical distancing between the others. Therefore, if you stay away from 2 meters, at least you will be able to prevent that. And another thing, if you give a shake hand to the person, it can come through the hands. That is why initially it was suggested, don't touch your mouth, nose, and ears. Because if you touch these organs, it can come from one organ to the another organ and enters through these sources and infect the human being. So therefore, even hands, when we give a shake hand to others, it transmits from our hand to the other hand. That is why the Indian culture say namaste. Several heads of other countries also started doing this namaste after the coronavirus. So coronavirus has given us more discipline after it came here. But however, it is on a lighter vein. But what we need to understand is these are the ways that it is spreading through aerosols. Therefore, we have to take enough precautions to prevent its spread. And how do we reduce the hospitalization and how do we reduce the morbidities? This is where the preventive medicine comes into picture. So if you give the vaccine before the infection, at least the person gets immunity, and because of that immunity, they will be able to fight against the virus and they will be able to stop spreading. Spreading cannot be stopped if it is infected. At least it reduces the infection intensity. That means the symptoms can be reduced, the death can be reduced, the hospitalization can be reduced. So therefore, this vaccination helps us in a long way to prevent at least severe infection. So therefore, it is advised that everybody take the vaccines. And then if we look at the global scenario of this pandemic, a total number of cases so far are 36 crores 5,78,392 as on January 27. This is from WHO website. And the total deaths reported all over the globe are slightly more than 5.6 million. And the vaccine doses that are given all over the globe to prevent this or to precautionary measures that I have mentioned so far is almost 967 crores and 97 lakhs, more than that vaccines have been administered. Now, how many vaccines are available now? There are 27 vaccines now available all over the globe, and 90 vaccines are now still under clinical or preclinical studies according to WHO website. If we get into the India's situation in Bharat, we have total cases of around 4 crores 3 lakhs cases so far, and deaths reported so far are 4,91,500, slightly more than that maybe, and new cases reported. And right now our current load of disease is around 20 lakhs all over the country. And the vaccination in our country is almost 1.7 crores. Let me state here that it is the vaccination that has really protected a lot of our people in our country. We have seen the severity in the second wave. And after the second wave, everybody recognized the significance of vaccination. And due to this free vaccine that is given by the government, and the governments have taken appropriate steps to distribute this vaccine, and almost 1.7 crore vaccine doses have already been distributed. That means we are racing against the infections of the virus. So if virus is spreading, we have to give vaccination much faster rate than the virus. So that is what happened. This is sailing against the tide in a sea. That's what actually we have achieved. It is a great achievement in our country. Not only that, If we look at this particular picture, this shows the overall situation on what is our country's this one. This is the first wave. We have small number of cases. And this is the second wave and more severe, where the Delta variant has shown its severity and lots of deaths. And the significance of vaccination also recognized during this time. And vaccination has improved quite a lot. And this is the current situation. This variant is Omicron, and it is the Omicron which is creating the pandemic now. And luckily, this Omicron is slightly a milder one. That means less number of hospitalizations. This less number of hospitalizations is not only due to the Omicron, but also the kind of achievement that we have through our vaccination process, and also the herd immunity that people have already got, and also the precautions that the government has given, and the people are taking those precautions, all put together, because this pandemic is a collective effort. Unless we put collective effort, we will not be able to contain the pandemic. But I am confident with the way that the things are going, particularly in our country, we have been able to make our own vaccines, and we are able to distribute it to all the people, and we have created enough programs for creating awareness on this through social media, through TVs, through various other channels, through government, and through several other mechanisms that we have, and through individuals, those who knows these things, consulting the doctors nowadays with the latest available technologies. We have been able to at least to reduce the damage that otherwise it would have created. So certainly we have reduced a lot of damage that it was supposed to create if we have not taken these measures, and our country has done extremely well in this particular case. Now I will quote here a report from Nature. Nature is one of the leading scientific journals. It talks about this corona variant. All the researchers have sequenced millions of SARS-CoV-2 genomes. They might simply have missed a series of mutations that evolutionarily led to Omicron. That means how Omicron has evolved. Is it a natural process of evolution of the virus? In understanding, maybe what this line says, we might have missed some of the intermediate points, and we have taken a final point of Omicron. This is what that means. The amount of genome sequencing that we have done is only through a strategy. So whether 5% or 10% of the population, those who are infected, are the cases that are being done. And in some cases, that is also if it is difficult, because genome sequencing of the virus takes 3 to 4 days. And then through genome sequencing only we will be able to detect the mutations or the variants that are occurring in this. And what variant is occurring, we will not be able to predict. Here there are two things that happens. When we have an mRNA virus, its natural tendency is that it mutates. So variants formation is a natural process. Scientists cannot predict what mutation is likely to come. Second, what this mutation will do. What does this mutation mean in the public health? These two cannot be predicted. So therefore, only when you get the variant and how it is infecting, then only our science develops. So we are a little behind in understanding this process, and it takes more time. It is not easy to understand this. So therefore, it is very, very important to take all the precautionary measures that were in place, or these precautionary measures, whatever are the measures changing from time to time, we should follow them. So the variant might have evolved mutations in one person as a part of long-term infection. We do not know. It could have emerged unseen in other animal hosts, such as mice or rats. We do not know. So there are various science has to be done, but this pandemic will not stop till we do the science. So therefore, clinical interventions and intelligent guess in treating the patients is very, very important. This is where we should understand the global patterns at various places, what is happening, and we may have to adapt some of them, because this is a biological infection with a biomolecule, and then at the same time we are injecting biomolecules into the body to prevent it. So therefore, understanding this in the long-term effects is still unknown, because if a variant comes, what happens in the long term? If the virus infects, what happens to a person after it reduces? What are the post-COVID symptoms in the short term, in the long term? We know only in the short term, but we do not know in the long term. This is where a lot of data has to be generated to understand this in a much more fashion. So coming to the vaccines that are available, which I gave you numbers, there are several technologies that are available. One, inactivated and weakened virus. What we have, Bharat Biotech, what is preparing is an inactivated or this virus, and directly using that virus, they are developing the vaccine. And we have the Serum Institute Covishield, that is through vector mediated, adenosine virus vector. They have incorporated this spike protein into that, and then that is the one that is used. So therefore, but these things are specifically directed towards the spike protein. The spike protein means which was allowing the virus to enter into the cell. So it creates blockage to that one or neutralize the virus through the antibodies that are produced. And here there is one more point that I need to add, and there are other technologies also in our country. Our country has produced the first vaccine with the DNA-based vaccine, Ks Gandhi, which they have produced a vaccine, and it already got emergency use authorization, and the guidelines for its use are in process. Once those guidelines comes, then it can be administered, and it is a 3-dose vaccine. Initially, it was thought for children, but whether it can be used for others also is still something that we have to wait and then see. And these 2 vaccines are in use. The inactivated virus also is used, but that works in a different way, and other vaccines works in a different way. But ultimately, all these vaccines are mostly directed towards the spike protein, except the inactivated one, which is on the entire whole inactivated virus. So therefore, the people who get immunity for this, they get a broad range immunity, broad immunity as compared to the other highly specified things. But which vaccine is good, which vaccine is bad? All vaccines are good. I use them. And coming to the one more important question at this stage, what about these booster doses? Booster doses means actually the 3rd dose. Initially, what is called first dose is the priming dose. 2nd dose is called the booster dose. The 3rd dose is not that one. That is already booster dose is already given. So that is why it is already a new word also is coined, preventive dose, or precautionary dose. Precautionary dose is given. So 3rd dose, is it really required? There are 2 different. It's a debatable point. Why it is debatable point is when a vaccine is administered to a person, he get initially antibodies in the body, and these antibodies may last around 6 months, 3 months, depending on the virus that depending on the vaccine that they have taken, and up to 8 to 9 months also, some of them are sustainable. And our body does not keep any unwanted material in our body. Even antibodies are unwanted in the long term. So they will also be reducing. They will get out. They will throw them out. So if antibodies reduces, does it mean the immunity is lost? The answer is no. The basic immunology that says when you administer a vaccine like this inactivated virus, it gives a cell-mediated response. It is a 2nd level of response. That is, antibodies will give humoral immunity, and this gives cell-mediated immunity. What is cell-mediated immunity? When a vaccine is administered, in our body we have B cells and T cells. These B cells and T cells have memory B cells will be there, which memorizes that a particular specific virus or its corresponding vaccine has entered into your body. Because it entered into your body, these cells remember that so and so virus entered into the body. But actually, when infection comes, even though the antibody is reduced, these cells start activating, and they can neutralize the infected cells with the virus, or they can also produce antibodies at that stage again. So therefore, there is another line of protection, immunity that is there. This is cell-mediated immunity. So therefore, those who want to take the 3rd dose, just consult with the doctor, see the amount of antibodies that are present. And another thing that I want to add, another important point particularly relevant here is, in our country, we have given vaccination to all the people, those who are uninfected. Only around 3.5 crores or so who are infected. For them, it is given separately. They don't require the vaccination of the normal uninfected people gets. So uninfected people also, earlier, some of them may be moderate to mild, exposed to other variants that are there. So those moderate to mild infected people already produce some antibodies like a priming dose in their body. And then we have given them a vaccine. So that means they get hybrid immunity or super immunity, this is called. That means definitely more people have better immunity. So therefore, for taking a 3rd dose, certainly take the advice of the doctor before administering a 3rd dose. This is very important. So therefore, that is regarding the booster dose. And in our this one, This I have already told you. Our country has, globally, there are 27 vaccines are in use right now. Use means either emergency use authorization or in use, and 90 are preclinical or clinical stage. So vaccines are being developed, including nasal vaccines. Nasal vaccines means the technology is varying. You can use a nasal spray. We don't require an injection. So that nasal spray is also another advancement in the vaccination that is also coming. That is also coming from in our own country from Bharat Biotech. So therefore, during the pandemic time, our country is stood up for the right time and responded to the pandemic right from the beginning of when we don't have any information on the virus. We have developed the detection kits, we have developed the personal protection equipments, and we have produced the vaccines, and we are also involved in developing the drugs. So therefore, our country is the scientists and the doctors that we have and the biotechnology companies together are rising to the occasion, and they have been able to make this vaccination and this whole process a grand success. Even though now we are in the middle of vaccine, the severity is less because of all the measures that they have taken and the experience that doctors have gained so far. Here, now my time is running out, so I would like to rush through. Why I want to put this protein therapeutics is an important aspect. How scientists are really, not getting appropriate support when it is required. This is a clear-cut case. I just want to present in a few 1 or 2 minutes and go for the conclusion of my talk. Here, there are different ways to express the proteins for the therapeutic response. The basic, which I told you in the beginning, is DNA produces RNA and that produces protein. Now, scientists asked, if we have directly injected the RNA into the body, why don't it produce the protein? And can we make proteins? This is protein therapeutics. And the protein is the one which helps to recognize the antigenic sites, and that produces the antibodies in the body. So therefore, if you directly inject, it should give, but there is a problem. If you directly inject the mRNA into the body, it gives inflammatory reaction. So therefore, this inflammatory reaction cannot be contained in RNA undergo degradation. So we have to prevent the degradation of this and prevent the inflammatory reaction. This is where Dr. Katalin Karayko, she is a Hungarian scientist, and she spent almost 30 years of her time in researching this RNA, and she has seen several uphills when she was doing. When she submitted this projects, there is nobody to support her, this idea. And people said, you are doing something which is unfundable. So neither government organizations nor private people are willing to fund her, but she relentlessly struggled and then keep trying on this particular technology. And ultimately, she got a success with her collaborator. That what she did, she used modified, I told you in the beginning, cytosine, adenosine, and guanine. These are the uracil are the ones which are present in the RNA. And these, she has modified them. And these modified chemical moieties, that is methyl cytosine or methyl adenosine or methyl uracil, if you incorporate these into the RNA and directly inject the RNA, she found that the inflammatory reaction is reduced and it is able to recognize these sites and able to synthesize the required protein. This is the breakthrough that she has obtained after a struggle of around 30 years. And then this led to the technology development of mRNA vaccine. These two companies, Moderna and Pfizer BioNTech, this Karayko Katalin, she works as a vice chairman or chairman in the biotechnology BioNTech company. And she is the one who struggled for developing this. The moment she saw the genome sequence that has emanated from Wuhan, immediately jumped into the problem and started preparing the vaccine for that mRNA vaccine. And that we now know all the success story, that it is now became a multi-dollar business and saved the lives of crores of people across the globe by the vaccination that she has done. And she spent all the 90s in collecting rejections for her grant, both from government and corporate. But she relentlessly fought. If there is somebody in her place, maybe perhaps would have left this problem, but she did not leave the problem. And she has the faith in the technology, and she felt that she will be able to achieve this. And she captured that, and ultimately she achieved the goal. And now these are the papers she has published. I'm not getting into that. The same, I have already told you the content. So therefore, the RNA-mediated immune system she was able to control, and she is able to produce. And the story does not end here. And now, for the technology and the achievement that she has. Now she has funding so much. Money, dollars are falling on her, where she cannot even count, for the technology that she has done and saved lives, billions of billions. Certainly, a person like that will deserving a Nobel Prize. Hopefully, she may get it soon. We do not know. So, in developing these vaccines, there is a major problem. What happens? Whichever country prepares these vaccines, they want to use it only in their own domain, in their own country. They don't want to supply vaccine to others. Yeah.
Can I request you to conclude it, please?
Yes, I am coming to conclusion. I'm coming to that. So therefore, with this problem, there are several people who get unvaccinated. So the pandemic right now we are facing is the pandemic of the unvaccinated. And the variants that are coming is from those who are unvaccinated. When we look back into our country's pandemic history, in the second wave, at that time, our vaccination was very, very less. So Delta variant emerged from this country. And if you look at South Africa, this is another country where vaccination is very poor. Omicron variant has developed. So therefore, vaccination seems to be a very, very important aspect. These people should go. And this is where we made our own vaccines. We administered vaccines in our own country with our own technology. This certainly we can say Atmanirbhar Bharat, particularly in the case of vaccination. Our biotechnology companies have been able to cater the needs of our country and raise it to the occasion. And this is where we have been able to protect our own people. And the role played by Wuhan and also the WHO are still where this virus has emerged and what is its origin is still undergoing. We do not know whether it is a lab leak or whether it is came from animal. Let them be there, but the pandemic did not stop. So we have to prevent the pandemic and simultaneously understand. This understanding is important, whether the natural evolutionary process can explain these mutations, or if it is unnatural virus, these natural mutations cannot be explained by that. So therefore, it is important to understand this from that particular point of view. So vaccines importance we have already discussed, and under the able scientists and the capable scientists and excellent biotechnology companies in India, we have been able to make this great achievement of vaccination of all the people and prevented a very big catastrophe in the country. And this is our great success. And now I end my talk at there. But I just want to add one slide towards the end. This is food for thought. What is this food for thought? Now, the technologies have becoming so strong. Even governments are losing control. So what are these emerging technologies now? Our earlier speakers also spoke from IIT. He said how we can use these technologies in a proper way and several other talks. Cryptocurrency, social media, artificial intelligence, and coronavirus, which we are seeing. You have only control over initial process, we don't know. Even that also we don't know if it is leaked accidentally from a lab. So therefore, we are entering into an area where the control goes from government to the technologies. Cryptocurrency is not controlled by any government. So therefore, it is very, very important on how to control these technologies and make them useful to humanity, and how the governments are now coming out with the new policies is something that people have to ponder about. And I'll put it at this for leaving for thought process. Thank you very much for giving me an opportunity. Thank you very much. And if there are any questions, I am willing to take.
Thank you, Jagannatham. We all know the story, but listening from you gives us more insights. And we also feel happy that together, Indians have done extremely well to control this disease. Thank you very much. Now, we'll give a chance to Dr. Gandhi. Otherwise, we can wind up after some questions. Dr. Gandhi, are you around? Okay, you are sharing the screen. Very good. Try, please. Yeah, Dr. Jagannathan, will you stop sharing?
I'm stopping here. I'm stopping
Excellent.
the presentation. Yeah. Trying to.
You have not stopped. If you stop, I think
that's what I'm doing. I'm just trying to do that. Trying to get into my screen. It's not stopped now. Screen sharing.
Okay, I did it. I did
Yeah.
it.
Yeah. Now I did it. Yeah.
Okay, now, Dr. Gandhi, will you be able to upload your screen, PPT? Unmute చేసుకోండి, please.
Could you see, sir?
Gandhi, yeah, Dr. Gandhi garu, మీరు రెడీగా ఉన్నారా?
Yeah, I'm ready. I'm ready, and also my screen is also there. My PPT is already there on the screen. You are able to see?
మూర్తి గారు మ్యూట్ చేసుకోండి. మూర్తి గారు మ్యూట్ చేసుకోండి.
Yes.
మూర్తి గారు మ్యూట్ చేసుకోవాలి. మూర్తి గారు మ్యూట్ చేసుకుంటే బాగుంటుంది. ఓకే.
Sir, I'm audible?
You are audible, but we can't see the screen.
Still not able to see.
లేదండి.
We'll share the screen. We are seeing only your face.
I don't know really how it has happened. Vijay Prakash garu.
So what we do is we have about 10-15 minutes now. Before we close down at 1:45.
Okay, sir, I will do one thing, sir. I will circulate my PPT to you. You kindly just make it available to the all the participants we have attended today. Okay, sir?
Thank you.
Sorry, thank you very much. I will in fact, I have already mailed to you.
Gandhi, you can just explore.
Yeah, I will just explain 2-3 minutes. I will explain to you. I will not take more time. Well, if I am audible, I will just explain to you. See, today our installed capacity of the renewables. I am focusing on the renewables because we are talking on this environmental aspects only. Before I proceed further, before I proceed on the environmentals, well, even for the conventional power plants in the country today, because our, as you know very well, that coal is our mainstay throughout the last 70 years. We have been developing the coal plants only, and that will be in fact it will in fact feature us also for the stability and for the reliability of the power system so far. So even in that also in that commercial conventional power plants, we have got a lot of changes in the case of as when this environmental aspects, environmental norms. For example, a lot of changes in the case of NOx and SOx, and people have been insisted that to go in for FGDs. Most of the thermal power plants, including NTPC plants, and they are, although earlier they were not there, but now people are putting these FGDs. For example, FGD is the flue gas desulfurization. And even for a 500 megawatt FGDs, for example, a 500 megawatt is almost one FGD is equal to cost of a boiler. So something like that. They're all investing, but people are investing, and all the new power plants, they are not getting into any commercial operations unless they also commission the FGDs. FGDs for the desulfurization, SOx, NOx, and also this SPM also. That's your specific your particulate matter at the stack elevations. Those are all have been actually, why I'm telling. So those norms have been tightened even for the thermal power plants, the conventional thermal power plants, which were not there earlier. Okay. Coming to the main thing which I'm trying to just discuss today, that was environment, your renewables. The renewables which we are talking about, the renewables, that is on this because of this Paris Agreement. Paris Agreement, because India is one of the.
Dr. Gandhi, I'm showing the slides. Are you able to see them? Or anybody able to see the slides?
I'm seeing.
Yes,
Anybody else?
I am able to see.
Yeah, they are visible.
Excellent.
Yeah,
So
sir,
what-
next, if you can just scroll it, I will say, I will tell you, I will just read out, sir, just next.
Okay.
As per, I mean, the India's commitment as per the India's, intentionally determined commitments as a fallout of the this Paris Agreement, we are going for 175 gigawatt. Actually, by 2030, India is planning to have about 40% of the installed capacity. 40% is the target which India sets in for its 40% of the installed capacity by 2030 by renewables, the non-fossil fuel resources. In between, by 2022, India is planning to have, India has already committed for 175 gigawatt of the renewables. What is this 175 gigawatt? 175,000 megawatt of the renewables. And today we are already having the renewables of about 104 gigawatt. That is 104,000 megawatt renewables we have. That is today is already commissioned. It is already in the grid, in the system, in the in the network. So that means they're all grid connected. Mind you, they're all grid connected. They're not standalone which you are talking. That is 100. See, the target is 175 gigawatt. That is 100 gigawatt of solar and 60 gigawatt of wind. This 100 gigawatt solar also, of course, it consists of both the rooftop as well as the utility scale. Both are grid connected only. See, with this, and see, what are the issues actually? That's what I was trying to just deal in this particular presentation today. And with this, when we are going for large scale integration of renewables, in the country today, we are almost replacing these thermal power plants, the conventional power plants. Conventional power plants which are not efficient and which are working at very low power factor, low PLF, that is plant load factors, and which are not also considered to be efficient in the way, for example, for the heat rate considerations. They are going to be removed from the system. They are going to be removed. About 40,000 megawatt have been already identified. So in this connection only, I have actually, I wanted to deal with some of the observations or some of the findings given by a committee report. The report was actually under the broader concept of the greening the grid. Under that, actually, a report was prepared for this 125 gigawatt, these implications and the impact of 125 gigawatt on the power system in the country today. And that was a report made by this Ministry of Power and in association with the USAID and also other entities like the NREL and also Berkeley Laboratories and all that, including other companies, the Indian companies like POSOCO, Power Grid, and other some other experts. So that report, as per that report, actually it has dealt with this 175 gigawatt, and of course for this 2030 also, 2030 scenario, that is about 400 gigawatt, that is the 40% of the industrial capacity by renewables. That commitment also they have made an interim report. That report is also available, and of course beyond that will take some more time for us to understand how this whole network is going to be recast for the entire the country. But at the moment, 175 gigawatt, we can think of how this is coming to, because we are almost very close to that the target. Today is already we are having 104 gigawatt, and by the end of this 22, probably we will reach even beyond this 100 gigawatt solar and 60 gigawatt wind. Okay. And in the process, we are also replacing these conventional power plants which are not efficient. At the same time, and there are some other issues like when we are operating this integrated mode, these renewables are also as a part of the system. The system, you see, what is the main objective, main criteria of the renewables? Renewables are all, this particularly solar and wind. They are not actually variable. They are variable nature. the generation is the resource is variable. At the same time, they are also unpredictable and probably not very much. You can't estimate. Actually, you can't forecast what will be the extent of that particular resource. So in the process, that means you are adding a variable and uncertain resource in the system, which is already established system. Because see, variability, okay, variability, we know that our power system, our system engineers, they have already gone through this particular variability of load. Load demand itself is not constant as of now. So whatever variability of that particular load, we know that how to deal with that particular variability, but not to this extent of this renewables. These renewables of such a large extent of renewables, it will give a lot of other impact on the other services like these ancillary services, these reactive power controls. Reactive power control, they are all system related matters. Before that, I just want to convey only one or two things. The thermal power plants are today are the victim. A conventional power plant has become conventional power plant has become a victim. No problem, but that because you will have to accommodate. One way you will have to do this going for renewables. That renewables we can't. There is a commitment of the country. So that means. So what is that actually we'll have to do? See, these are all power plants are all built for over years. But although thermal power plants are quite efficient in some of them, like this supercritical technology we have gone for. We have most of these thermal power plants. Have been gone for. Actually, we have gone for supercritical technology for last all 660 and above 800 megawatt. They're all supercritical technology. So at the same time, we are having old plants also, but the old plants and this recent plants, all the thermal power plants, what will do? Okay, we are going to replace with the inefficient thermal power plants and with this. Okay, that is okay. That is because we are going for renewables. But the thermal power plants, there are certain restrictions like loading of the thermal power. You see, with thermal power plants, we cannot operate less than below 70% of the loadings. Because of that, because it is OEMs, original equipment manufacturers, their restrictions. At the same time, there are certain other restrictions on this ramp rates. That means you cannot load the power plant unit more than 1% per minute. So all these restrictions will have to relook or probably remodify them, because those thermal power plants will have to accommodate their this thing in this scenario where we are putting large quantities of large renewables. So those areas, these are all coming up not only in this operational aspects and some sort of commercial aspects also, because a lot of all the thermal power plants are already tied up with back-to-back power purchase agreements, and these power plant the power purchase agreements are all having there are regulations, CRC regulations, tariff regulations are all there. So with that, how do you mitigate that? So how do you go about with this thermal, the renewables operation? This is what actually, those are the areas which I wanted to convey. That is one thing. That means the operational aspect of this system, along with, will have to go along with the renewables. But the thermal power plants also will be there in the system until we completely replace them. Until we completely replace them, we'll have to deal with that. We'll have to live with that also. But they become the victim. They become the victim in the sense that the thermal power plants operations in the minimum loadings. So that's why the regulation, Central Electricity Regulatory Commission, they have reduced, actually they have given they have notified this minimum loading of the thermal power plants of the central sector thermal power plants to 55% recently. So that means there is already they have given the minimal loadings. But minimal loadings have other implications. For example, if you are operating a thermal power plant at a partial loading at the minimal loading partial loadings, there is the heat rate implications are there, the heat rate degradations are there. So for that, they have also given another regulation. So heat rate compensation. and the other ramp rate, of course, the ramp rate compensation, those things have been actually, they have come out. But those compensation elements have been actually notified for the with respect to the central sector, the conventional thermal power plants. But what about the state sector? State sector also, all the states, they are having their own plants. So those plants also should come up in the same way, and they also should work in the same way. So that type of things, actually, that's what actually I wanted to convey. When the report published by this group, actually, as I said, under the caption of under the broader caption of the greening the grid. That is the report. In fact, it will be there are 2 volumes in that, volume 1, volume 2. Volume 1 is the national report, and volume 2, of course, that deals with the specifics to the southern region and western region systems. And they have given that there are certain findings in that. As per that, government and the regulators, they are all working. And that is one area of the integration of the renewables along with the thermal power plants, existing thermal power plants. So that's why these thermal power plants have to be notified for their operations, for their the loadings, for their ramp rates, for their stops also. You cannot expect a thermal power plant to start and stop unless some minimum timings are there, minimum hours are to be left. Then only you can restart the machine. Some like that. Those things are also number of starts, number of stops. Not only that, for each start there is a lot of oil, a lot of the fuel has to be spent. So those also they have given some compensations. All those things are there. But at the same time, whether the state sector power plants are also, they also have to come in line. Then this whole thing, this will work like what actually is intended to be the targets, like this carbon emissions and all that. And ultimately our aim is to go in for country's aim is to go in for net zero carbon by at least, if not by 2030, at least by 2050. So that is one area. And other areas like how much actually this when you are operating with the renewables, the other issues like this how do you rest, of course those are all slightly system related topics like system restoration and these active power controls, reactive power controls, and the reserve capacity controls, reserve capacity management. So those things are also there. So it is as though our commitment is there, very much there. But this commitment, but to fulfill this commitment, there are other things also have to be looked into. So that's what actually I wanted to just to show this, how this whole integration is to be tackled. And as the day, during course of the day, period. So all these things will be sorted out. There are regulators, and then both the central sector, central regulators and state regulators, system operators, and system load dispatch centers, operators. They're all there. Everybody is working on it. But ultimately, our aim is to see that we will go in for zero carbon. That means net zero carbon. That is our target. At least, if not by 2030, by 2050. Thank you. This is what actually I wanted to convey in the form of, about 30-35 slides, but I am very sorry. I will give this presentation to share with you, and you kindly just go through that, sir. Thank you. Thank you very much. I will not take my further time.
Thank you, Dr. Jagannatham. I showed the slides. All 39 slides I showed, including the handshake at the end.
Yes, sir. Yes, sir.
I'll share with the people.
Yes,
friends, we are almost at 2 o'clock. I don't want to further continue. I've been patiently sitting and listening to all the people, including our eminent speakers. I've left my phone number in the chat box. Those who want to contact me for contacts of the speakers, I will share with you all. Whoever wants to contact me, I'll share the numbers to you all. And personally speak to the speakers and get all the questions done. And as far as I'm concerned, it has been an exhilarating day for me to learn so many 6 topics. We missed Dr. Divakar because of technology problems. but I think it's a very enriching day for me. I'm sure it's for you. And, it's like in the classroom, you get first period math, second period physics, third period language, fourth period this. The 6 lectures are different areas, but I'm sure they're all addressing the society and the human health, human happiness. Thank you very much. And I'm delighted and totally indebted to you all for being here, spending time. And now Prerna, you may finally invite Dr. Murthy Kocharla, VRS Murthy Garu, to say final words of thanks.
I would personally like to thank all the speakers for sharing their valuable time in sharing their valuable information on topics given to them. Thank you very much. It was an amazing day to listen to all of you. I would now like to invite VRS Murthy Garu to give vote of thanks.
Today is a wonderful day. Hello? Hello?
Yes.
Is it audible?
Yes, audible.
One second. It's a wonderful day. We had very good talks on energy, environment, and all the very expertized people like Jagannathan and Babu Rao has given wonderful solutions how the government has to act and all that. And Jagannathan on the vaccine and this one, and Rao Garu, Dr. Gandhi on how by renewable energy, how the carbon emissions can be controlled and all that. And other speakers from John, he has given a wonderful how the medical apparatus will be defined and designed and supplied. And let us hope that type of medical use will, the hospitals will be empty. Let us hope that. And EPTR Prasad has given a wonderful lecture. And Dr. Anita from University of Hyderabad has shared her valuable lecture, and this is all given thought, and more we have learned a lot in this, and people must do the environmental, how we have to control and all these things. I must thank all the speakers personally, and on behalf of Indian social science economy, I thank everyone profusely, and a wonderful day. Thank you, Dr. Ganeshan, who has taken initiative to make this type of efforts to educate our people through social sciences. Thank you very much, and I thank Prema for sharing this grace and making it a very lovely symposium today. Thank you very much.
Those are the final words from me, and it's my privilege. Have a good lunch, a delayed lunch. Prerna, we hats off to you. You have done it so wonderfully, connecting all of us, missing none. And I appreciate the patience of Dr. Gandhi coming 2-3 times to share his knowledge. Appreciable very much. And that's it. Thank you very much. Have a great day. I'm sure we'll meet soon sometime in person.
Thank you, sir. Thank you very much.